probability. 145. 5.1 Statistics. 146. 5.2 Probability. 185 Key terms. 213 Summary. 213 Review exercises. 216. Unit 6 Matrices and Determinants. 219. 6.1 Matrices. 221. 6.2 Determinants and their properties. 234. 6.3 Inverse of a square matrix. 241. 6.4 Systems of equations with 2 or 3 variables. 246. 6.5 Cramer's rule. 256 Key terms. 259 Summary. 259 Review exercises. 262. PQ PQ QP TT TT FFT FTT FFFTT 3 X Y 2 2I 1 plus 4I 3 plus 2I. Unit 7 The set of complex numbers. 265. 7.1 The concept of complex numbers. 267. 7.2 Operations on complex numbers. 269. 7.3 Complex conjugate and modulus. 274. 7.4 Simplification of complex numbers. 279. 7.5 Argand diagram and polar representation of complex numbers. 283 Key terms. 290 Summary. 290 Review exercises. 291. Unit 8 Vectors and transformation of the plane. For natural science students. 293. 8.1 Revision on vectors and scalars. 294. 8.2 Representation of vectors. 301. 8.3 Scalar, inner or dot, product of vectors. 306. 8.4 Application of vector. 311. 8.5 Transformation of the plane. 320 Key terms. 343 Summary. 343 Review exercises. 345. Unit 9 Further on trigonometric functions. For natural science students. 347. 9.1 The functions y equals sec x, y equals CSC x and y equals cot x. 348 9.2 Inverse of trigonometric functions. 353 9.3 Graphs of some trigonometric functions. 361 9.4 Applications of trigonometric functions. 377 Key terms. 393 Summary. 393 Review exercises. 396 B. A theta O. Theta. 4. Unit 10 Introduction to Linear Programming. For social science students. 399 10.1 Revision on linear graphs. 401 10.2 Graphical solutions of systems of linear inequalities. 403 10.3 Maximum and minimum values. 407 10.4 Real-life linear programming problems. 416 Key terms. 422 Summary. 423 Review exercises. 423 Unit 11 Mathematical Applications in Business. For social science students. 425 11.1 Basic mathematical concepts in business. 426 11.2 Compound interest and depreciation. 439 11.3 Saving, investing, and borrowing money. 453 11.4 Taxation. 462 Key terms. 472 Summary. 473 Review exercises. 473 Solution region. 1 2 3 4 1 2 3 4 4 3 2 1 1 2 X Y 2x y equals 0 x plus y equals 3 5 Unit outcomes. After completing this unit, you should be able to know specific facts about relations. Know additional concepts and facts about functions. Understand methods and principles in composing functions. Main contents 1.1 Revision on relations 1.2 Some additional types of functions 1.3 Classification of functions 1.4 Composition of functions 1.5 Inverse functions and their graphs Key terms Summary Review exercises. Further on relations n. Functions. Unit 1. Mathematics Grade 11. 2. Introduction. Relationships between elements of sets occur in many contexts. Examples of relations in society include one person being a brother of another person or one person being an employee of another. On the other hand, in a set of numbers, one number being a divisor of another, or one number being greater than another are some examples of relations. In grades 9 and 10, you learned a great deal about relations and functions. In this unit you will study some more about them. We hope that your understanding of the concepts will be strengthened. You will also study some additional types of functions. Historia el note. René Descartes, 1596 to 1650. René Descartes was a philosopher and a mathematician, who assigned coordinates to describe points in a plane. The xy coordinate plane is sometimes called the Cartesian plane in honor of this Frenchman. Descartes' discovery of the Cartesian coordinate system helped the growth of mathematical discoveries for more than 200 years. John Stuart Mill called Descartes' invention of the Cartesian plane the greatest single step ever made in the progress of the exact sciences. Opening problem. A set of glasses that are in the shape of right circular cones are to be made for display as shown in the adjacent figure. The glasses have the same height, h equals 50 centimeters. If the volume of a cone, V, as a function of r, is given by the formula 1, 2, 3 VFRHR equals pi. Can you express r equals f-1, V? Can you fill in the following table? Measurements are in cm. Round r to 2 decimal places. V40 80 120 160 200 240 280. R. Can you draw the graph of f-1? Figure 1.1. Unit 1 Further on relations and functions. 3. 1.1 Revision on relations. 1.1.1 Inverse of a relation. Activity 1.1. 1 Let A1, 5, 6, 7, 8, and B1, 2, 4, 9 equals B2 sets and R equals 5, 1, 6, 4, 7, 9, 8, 2, 1, 1, be a relation from A to B. Give the domain and the range of R. 2 Let R equals x, y, x. Note, a relation is a set of ordered pairs. Given two sets A and B, a relation from A to B is defined as any subset of A times B. A relation on A is any subset of A times A. Let R be a relation from A to B. Then, domain of R equals X, set membership symbol A, X, Y, set membership symbol R, for some Y, set membership symbol B, range of R equals Y, set membership symbol B, X, Y, set membership symbol R, for some X, set membership symbol A. If R is a relation from A to B, then you may want to know what the inverse of R is. The following definition explains what we mean by the inverse of a relation. Definition 1.1 Let R be a relation from A to B. The inverse of R, denoted by R1, is a relation from B to A, given by R1 equals B, A, B, set membership symbol R. Example 1 Let A equals 0, 1, 2, and B equals 5, 6. Give the inverse of R equals 0, 5, 0, 6, 1, 6. Solution: A, B, set membership symbol R means B, A, set membership symbol R1. Thus, R1 equals 5, 0, 6, 0, 6, 1. Mathematics Grade 11. 4. Example 2 Let A be the set of all towns in Ethiopia, and B be the set of all regions in Ethiopia. If R equals A, B town A is found in region B, then find R1. Solution: Notice that the first element of any ordered pair in R is a town, while the 2 and D element is a region. Thus, in R1, the first element of the ordered pair should be a region while the second element should be a town. So, R1 equals B. A region B contains town A. Equals A. B region A contains town B. Example 3 Let R equals X Y Y X equals plus 3. Find R1. Solution: in R, the second coordinate is 3 plus the first coordinate. Thus, R1 equals YXXY, R, set membership symbol equals XYYX, R. Set membership symbol equals XYXY, 3. Equals plus. Notice that the first coordinate is 3 plus the second coordinate. Equals 3XYYX equals. Solve for Y. Example 4 Let R equals X, Y less than or equal to X plus 3 and Y 2X plus 6. Give R1. Solution R1 equals y x y less than or equal to x plus 3 and y2 x plus 6 equals x y x less than or equal to y plus 3 and x2 y plus 6 equals 1, 3 and 3 2 x y y x y x greater than or equal to plus GROUPWORK 1 1 if A equals 1, 2, 3, 4, 5, and B equals U, V, W, X, then which of the following are relations from A to B? AR1 equals 1, V, 2, W, 5, X. BR2 equals 1, V, 3, 3, 4, V, 4, W. CR3 equals 1, Y, 1, X, 3, V, 3, X. DR4 equals 2 for the relation in example 1 above. Find the domain and range of R. B. Find the domain and range of R. 1. C. Compare the domain of R with the range of R. 1 and the range of R with the domain of R. 1. What do you notice? Unit 1 Further on relations and functions. 5. 3 For the relation given in example 2 on the previous page, if Ambo town is in Oromia region and Jijiga town is in Somali region, which of the following is in R? 1. A. Jijiga, Somali. B. Oromia, Jijiga. C. Oromia, Ambo. D. Somali, Jijiga. 4 For the relation in example 4 on the previous page, find the domain and range of R. 1. 5 Give the domain and range of the inverse of each of the following relations. A 6R, 1, 5, 3, 6, 4, 3.5, 1, 5 equals. BR equals X, Y, Y equals 3x7 CR equals X, Y, Y. Exercise 1.1 Exercise 1.1 1 If R equals X, Y, Y greater than or equal to X plus 1, which of the following is true? A. 0, 0. Set membership symbol RB 0 Set membership symbol domain of R. C. 0, 1. Set membership symbol RD. 5, 6. Set membership symbol RE. 5, 5. Set membership symbol RF0 Set membership symbol range of R. 2 Let R equals X, y, y greater than or equal to x2, 1 and y less than or equal to 3. Sketch the graph of R. B. Give the domain and the range of R. 3. Give the relation represented by the shaded region in Figure 1.2. 4. Give the inverse of each of the following relations. AR equals X. YX is a brother of YBR equals X, Y, X2 plus 1 equals Y2 CR equals X, Y, Y greater than or equal to X plus 3 and Y. Figure 1.2. X equals Y2Y. X. X2 plus Y2 equals 9. Mathematics grade 11. 6. 1.1.2 Graphs of inverse relations. Activity 1.2. Do the following in pairs. Let R equals 1, 2, 3, 9, 4, 6, 5, 7, 5, 2.5. List the elements of R. 1. B. Compare the domain of R. 1 and the range of R. What do you notice? C. Compare the range of R. 1 and the domain of R. What do you notice? D. Do the same for R equals X, Y3 less than or equal to X less than or equal to 3, Y set membership symbol. E. How can you generalize your findings? From what you did so far, you should have concluded that domain of R, 1 equals range of R, range of R, 1 equals domain of R. Note, on the Cartesian coordinate plane, in keeping with common usage, arrows are used on the axis to show positive direction. If the boundary curve in the graph of a relation is not part of the relation, it is shown using a broken line. Now, let us compare graphs of R and R1 and see their relationship. Example 5. Let R equals X, Y greater than or equal to X2. Draw the graph of R and R1 using the same coordinate axes. Solution R1 equals X, YX greater than or equal to Y2. X, Y. X equals Y equals X2 2. 1 2 3 4 5. 1 2 3 4 5. 4 3 2 1 1 2 3. Figure 1.3. The graph of R and R1. Notice that Y equals X2 and X equals Y2 meet at 0, 0, and 1, 1. The equation of the line through the 2 points is Y equals X. Unit 1. Further on relations and functions. 7. Example 6. For the following relation, Sketch the graphs of R and R1 using different coordinate axes. R equals x, y, y. Solution R1 equals x, y, x. Equals x, y, y, x. 2 and y less than or equal to x plus 1. X, y. Y equals x1 equals x plus 2. 1 2 3 4 5. 1 2 3 4 5. 4 3 2 1 1 2 3 4. 5. X, y equals x plus 1. Y equals x2 1 2 3 4 5. 1 2 3 4 5. 4 3 2 1 1 2 3 4. 5. The graph of RB, the graph of R1. Figure 1.4. GROUPWORK1. 2 GROUPWORK1. 2. 1 let R equals 3, 1, 4, 2, 6, 3, 5, 1. List the elements of R1. B. On a piece of squared paper, sketch the line y equals x. C. Sketch R and R1 on the paper, using different colors, or marking points of R by asterisk and points of R1 by D. Fold the paper along the line y equals x. E. What do you notice? 2. Let R equals x, y equals x3. Give R1. Repeat the above investigation B to E for R. 3. Sketch the graph of R equals x, y. From the above group work, you should conclude that R and R1 are mirror images of each other on the line y equals x. This means, if you reflect the graph of R in the line y equals x, you get the graph of R1 and vice versa. Mathematics Grade 11. 8. Exercise 1.2. 1. Let R equals x, x plus 1 equals y2. Draw the graph of R1 by reflecting the graph of R in the line y equals x. B. Consider the following graph of a relation R. Figure 1.5. Which of the following is the graph of the inverse of R? I23. Figure 1.62. For each of the following relations, draw the graph of R and its inverse using the same coordinate axes. R equals x, y, x plus y less than or equal to 1. B. R equals x, y, y greater than or equal to x plus 1 and y. C. R equals x, y, x2 plus y2 equals 16. D. R equals x, y, x2 plus y2 16, y, x, y, x, y, x, y, x. Unit 1 Further on relations and functions. 9. 1.2 Some additional types of functions. 1.2.1 Revision on functions. Activity 1.3. 1. Which of the following are functions? AR equals 1, 0, 2, 0, 3, 1, 1, 6. BS equals 1, 0, 2, 0, 3, 1, 6, 1. CT equals 2, 1 x y y x dw equals 2, 9 x y y x plus greater than or equal to ek equals 1, 3, 3, 2, 1, 7, 1, 4. FL equals 0, 0, 0, 2, 0, 2, 0, 4. 2 Let f x equals 9x 2 and g x equals 3 plus 7x. Find the domains of f and g and evaluate the following. AF 2, BF 2 CG 3. Note: a function is a relation in which no two distinct ordered pairs have the same first element. If f is a function with domain A and range a subset of B, we write f A rightward arrow B or a B rightward arrow f. If f A rightward arrow B is given by a rule that maps x from A to y in B, then we write y equals f x. Example 1. Suppose f A rightward arrow B is the function that gives 5x, 1 for any x set membership symbol A. What are the possible ways of writing this function? Solution: we can write it as f x rightward arrow 5x, 1 or f x equals 5x, 1 or y equals 5x, 1 or x rightward arrow f 5x, 1. Note: f x is read as f of x. Y equals f x if and only if p x y is a point on the graph of f. Vertical line test: a set of points in the Cartesian plane is the graph of a function, if and only if no vertical line intersects the set more than once. Mathematics Grade 11. 10. Definition 1.2. A function f A rightward arrow B is said to be I odd, if and only if, for any X set membership symbol A, F, X, equals F, X. 2 even, if and only if, for any X set membership symbol A, F, X, equals F, X. The evenness or oddness of a function is called its parity. Example 2. AF, X, equals X3 is odd, since F, X, equals X, 3 equals X3 equals F, X. BF, X, equals X2 is even since F, X, equals X, 2 equals X2 equals F, X. CF, X, equals X plus 1 is neither even nor odd since F, X, equals X plus 1 is not equal to X plus 1, equals F, X, and F, X, equals X plus 1 is not equal to X plus 1 equals F, X. Note: exponential and logarithmic functions. Of function f, rightward arrow, 0 infinity, given by f, x, equals ax, a0, a is not equal to 1 is called an exponential function. Of function f, 0 infinity, rightward arrow given by f, x, equals log ax, a0, a is not equal to 1 is called a logarithmic function. If a0, a is not equal to 1, then log x x a x a equals. Exercise 1.3 Exercise 1.3 1. Draw the graph of each of the following functions. A 3 1, 2x fx equals bgxx, plus 1 equals cf, x, equals 4. 2. A researcher investigating the effect of pollution on plant life found that the percentage p, x, of diseased trees and shrubs at a distance of x km from an industrial city is given by p, x, equals 32 to 350 x, 450 less than or equal to x less than or equal to 500. Sketch the graph of the function p and find p, 50, p, 100, p, 200, p, 400. 3. Determine whether each of the following functions is even, odd or neither. Of 4gxx, 8 1 equals plus bf, x, equals 4x3, 5x. Cf, x, equals x4 plus 3x2 d1hx, x equals. Unit 1 Further on relations and functions. 11. 4. Use the vertical line test to determine the graph S that represent function S x y x y a b x y x y. CD Figure 1.7 1.2.2 Power Functions. Activity 1.4 Given the functions af x equals 2x7bg x equals xch x equals 4xd3 2fxx equals e2 equals 3xgx. Classify each as a power function or an exponential function. Definition 1.3 A power function is a function which can be written in the form f x equals xr, where r is a rational number and n is a fixed number. Note: don't confuse power functions with exponential functions. Exponential function, y equals ax, a fixed base is raised to a variable exponent. Power function, y equals xr, variable base is raised to a fixed exponent. Mathematics Grade 11. 12. Let us see the behavior of a power function when r is an integer. GROUPWORK1 3 GROUPWORK1 3. Do the following in groups. I when r is a positive integer 1 let f x equals 4x3 a. What is the domain of f? What is the range of f? B. Fill in the following table. x2 1 0 1 2 f x. C. Sketch the graph of f x using the above table. D. What is the parity of f, i.e. is it even or odd? E. Investigate its symmetry. 2. Go through the steps A to E for the function f x equals 4x2 2 when r is a negative integer. 3. Let f x equals 2x3 a. What is the domain of f? What is the range of f? B. Fill in the following table. x2 1 0 1 2 f x. C. Sketch the graph of f x using the above table. D. What is the parity of f, i.e. is it even or odd? E. Investigate its symmetry. 4. Go through the steps A to E for the function f x equals 2x2. We now consider the behavior of a power function when r is a rational number of the form mn, where m and n are integers, with n is not equal to 0. We will assume that mn is in its lowest term. Unit 1 Further on relations and functions. 13. Example 3. Draw the graph of 133 fxxx equals. Solution. The following table gives some values. X 81018, F X 21012. Using the above values, the graph can be sketched as X Y 1 2 3 4 5 3 2 1 4 3 2 1 2 3 1 8 7 6 5 6 7 8. Figure 1.8. Graph of f x equals 3x. Note 1 for the function f x equals 3x. Domain of f equals range of f equals 2. The point 0, 0, where the graph changes shape from concave upward to concave downward, is called an inflection point. 3. All functions 1 equals n f(x), where n is an odd natural number, have similar behaviors. They all pass through 1, 1, and 1, 1. They are also increasing. The following figures give you some of the various possible graphs of power functions with rational exponents. Y X 5 4 3 2 1 1 2 3 4 5 4 3 2 1 0 1 2 3 4 5. M Y X 5 4 3 2 1 1 2 3 4 5 5 4 3 2 1 0 1 2 3 4 5. MN M. Figure 1.9. Type of graph of y equals mnx. Figure 1.10. Type of graph of y equals mnx. M even, n odd, m odd, n even. Mathematics grade 11. 14. Y X 5 4 3 2 1 1 2 3 4 5 4 3 2 1 0 1 2 3 4 5. Y X 5 4 3 2 1 1 2 3 5 4 3 2 1 0 1 2 3 4 5. Figure 1.11. Graph of y equals 1 nx. N odd. Figure 1.12. Graph of y equals 1 nx. N even. Y X 5 4 3 2 1 1 2 3 5 4 3 2 1 0 1 2 3 4 5. Figure 1.13 graph of y equals mnx, m even, n odd. Note: the point P, 0, 0, in figure 1.9 is called a cusp. Activity 1.5. Answer each of the following for the functions given by figures 1.9 to 1.13 above. 1. What are their domains and ranges? 2. Give their parodies. 3. State whether they are symmetrical with respect to the x-axis, y-axis, the origin or neither. 4. Where are they increasing and where are they decreasing? Exercise 1.4. Exercise 1.4. 1. Which of the following are power functions and which are not? Give reasons. F x equals 5x2 plus 1 bf x equals 5x3 4cg x equals x2 dh x equals xxel x equals 5x plus 1. Unit 1. Further on relations and functions. 15. To find the domain of each of the following power functions. A 1 3 fxx equals b5 4 fx equals x, cf x equals 2 3 2 x d7 4 fxx equals 3. Sketch the graphs of f, g, and h using the same coordinate axes. F x equals x2, g x equals 2x2 and h x equals 2x2. 4. If f x equals xn, a is not equal to 0 and f xy equals f x f y, what is the value of a? 5. Consider f x equals x1, a is not equal to 0. A. Give the domain and range of f x. B. Suppose a 0. Then y equals f x can be written as a y x equals or x y equals a. Here x and y are inversely related and a is called the constant of variation. Draw the graph of f x when a equals 2, and describe its symmetry. 1.2.3 Absolute value, modulus, function. Activity 1.6. Find the absolute value of each of the following. A. 2b3c0d6.014. Definition 1.4. For any real number a, the absolute value or modulus of a is defined by if 0 a greater than or equal to equals. Some calculators have keys denoted by X or ABS. You can use such a key to find the absolute value of a number. In case you have a calculator that does not have such a key, to find x, enter x, press the x2 key, and then press key. This is based on the property 2x equals. Calculator tips. Mathematics grade 11. 16. Activity 1.7. 1. Compare the absolute values of A 3.5 and 3.5, B 4.213 and 4.213. See what can you conclude about x and x, for any x in 2. Compare xy and xy for the following. Ix equals 2.4, y equals 3, 2x equals 6, y equals 4. B. Conclude whether or not xy equals xy, for all x, y. Set membership symbol. Some properties of the absolute value. 1. X greater than or equal to 0 for any x. Set membership symbol. 2. X is the distance between the point corresponding to x and the origin. 3. X greater than or equal to x and x greater than or equal to x, for any point with coordinate x in. 4. X equals x, for any x. Set membership symbol. 5. For any x, y. Set membership symbol, provided that 0xx equals y is not equal to 6xy equals xy, for any x, y. Set membership symbol. 7. X equals a, if and only if x equals plus or minus a, provided a greater than or equal to 0. In case a. Definition 1.5. The modulus, absolute value, function is the function given by f, x, equals x. Note: domain of f equals. Since f, x, equals x greater than or equal to 0, for each x. Set membership symbol, range of f equals 0, infinity. Example 4. Complete the following table for f, x, equals x. X 3210123. F, x. B. Using the above table, sketch the graph of f, x, equals x and notice its features. Unit 1. Further on relations and functions. 17. Solution A. X 3210123 f, x 3210123 b. From the table, you can draw the graph as follows. X, y, 1 2 3 4, 4 3 2 1 4 3 2 1, 2 3, 1, 5 f x equals x. Figure 1.14 graph of y equals x. As you can see, the graph has no hole or break in it, i.e. it is continuous, and it makes a sharp corner or a cusp at p, 0, 0. The graph is also symmetrical with respect to the y-axis. Exercise 1.5 Exercise 1.5 1. If x equals 4 and y equals 6, then find a 4x, 3bxy plus 1c1xx plus 2. Give the solution sets for each of the following equations. Ax equals 4c, 3x plus 1 equals 0, bx 3 equals 1d, 3x plus 1 equals 5. 3. Give the domain of each of the following functions. Af x equals x plus 1 ch x equals 1 xbg x equals xx dk x equals x 2x. 4. Sketch the graphs of f x and h x given in question 3 above. Mathematics grade 11. 18. 1.2.4 Signum function. Activity 1.8. Consider the function 3, if 0 equals 2, if the domain of f be the range of f. C. Sketch the graph of f. Definition 1.6. The signum function, read as signum x, is written as sgnx and is defined by y equals f x equals 1, for 0 sgn equals 0, for equals 0 1, 4 x x x x. Since 1, 0 equals x x x does not exist, 0 1 equals, we have 0 sgn equals 0 equals 0. X x x x x is not equal to. Note: the symbol means does not exist or undefined. The signum function is an example of a piecewise defined function. If an endpoint of a curve is not part of the graph, it is shown by a small open circle. If an endpoint of a curve is part of the graph, it is shown by a small filled-in circle. Example 5. Complete the following table. X 4 3 2 1 0 1 2 3 4. SGNXB. Sketch the graph of f x equals SGNX using the above table and find its domain and range. Unit 1. Further on relations and functions. 19. Solution A. X4321012334 SGN X11110111B X Y 321 23 1F X equals SGN X 4321012345. Figure 1.15. As you can see from the graph, the domain of f x equals SGN is and its range is 1, 0, 1. Exercise 1.6 Exercise 1.6 1. Sketch the graph of f x equals x plus SGN x. Give the domain and range of f. 2. Draw the graph of f x equals x SGN x. What is its relationship with the graph of y equals x? 3. Sketch the graph of f x equals x2 SGN x. What is its domain? What is its range? 4. Sketch the graph of g x equals x3 SGN x. Give its domain and range. Does it have symmetry with respect to any line? 5. Is f x equals SGN x even or odd? B. Is f x equals x3 SGN x even or odd? 1.2.5 Greatest integer, floor, function. Definition 1.7 The greatest integer function, denoted by f x equals x, is defined as the greatest integer less than or equal to x. Example 6. Let x equals 2.56. On the number line, x is found between 2 and 3. 2 1 0 1 2 3 4. 2.56. Mathematics grade 11. 20. What is the largest among the integers that is less than or equal to 2.56? You can see that it is 2. Thus 2.562 equals. Note, the greatest integer less than or equal to x is also called the floor of x. Example 7. Find x when ax equals 4.6, b x equals 3, c x equals 7.2143. Solution A. 5 is the largest integer less than or equal to 4.6. i.e., 4.6 equals 5. B3 is the largest integer less than or equal to 3. i.e., 3 equals 3. C 7.2143 is between 7 and 8. Thus, 7.2143 equals 7. Activity 1.9. 1. Let f x equals x. Give f. 2. 2 3, 2, 7, 2.5, 1.01, b. What is f, x, when 3 less than or equal to x? 2. Draw the graph of f, x, equals x. Note: the greatest integer less than or equal to x is the integer that is immediately to the left of x, or x itself, if x is an integer. As you have seen from the examples above, x can be any real number, but x is always an integer. Thus, domain equals range equals z. We write this as f, rightward arrow z, given by f, x, equals x. x3 less than or equal to x. Unit 1 Further on relations and functions. 21. Exercise 1.7 Exercise 1.71 What is the value of each of the following? A pi b 21.01 c 21.01 d 02 given f, x, equals x. I verify that if K set membership symbol z, x set membership symbol, then fxk plus equals plus by taking a x equals 4.25, k equals 6, b x equals 3.21, k equals 7, c x equals 8, k equals 11. To verify that f, x, plus f, y, less than or equal to f, x plus y, less than or equal to x plus y, using a x equals 4.25, y equals 6.32, b x equals 2.01, y equals pi, c x equals 4, y equals 6.24. 3. Verify that fx 1 less than or equal to 1.3.11 to 1 functions. Activity 1.10. Which of the following is 1-to-1? F equals A, 1, B, 3, C, 3, D, 2, G equals A, 4, B, 2, C, 3, D, 1. Definition 1.8 A function f, a rightward arrow b is said to be 1-to-1, an injection, if and only if each element of the range is paired with exactly one element of the domain, i.e., f, x1, equals f, x2, x1 equals x2, for any x1 and x2 set membership symbol A. Note: this is the same as saying x1 is not equal to x2. F, x1, is not equal to f, x2. Mathematics Grade 11. 22. Example 1. Show that f, rightward arrow given by f, x, equals 2x is 1-to-1. Solution: let x1, x2 set membership symbol be any two elements such that f x1 equals f x2. Then 2x1 equals 2x2, 1 2 1 2, 1 1 2 equals 2 2x. Thus, f is 1 to 1. Example 2 show that f rightward arrow given by f x equals x2 is not 1 to 1. Solution: take x1 equals 2 and x2 equals 2. Obviously, x1 is not equal to x2. E2 is not equal to 2, but f x1 equals f 2 equals 22 equals 4 equals 2 2 equals f 2 equals f x2. This means there are numbers x1, x2 set membership symbol for which x1 is not equal to x2. F x1 is not equal to f x2 does not hold. Thus, f is not 1 to 1. When the graph of f rightward arrow is given, i.e. f is a graphical function, there is another way of checking its one-to-oneness. The horizontal line test of function f, a rightward arrow b is 1 to 1, if and only if any horizontal line crosses its graph at most once. Example 3 using the horizontal line test, show that f rightward arrow given by f x equals 2x is 1 to 1. Solution: from figure 1.16, it is clear that any horizontal line crosses y equals 2x at most once. Hence, f x equals 2x is a 1-to-1 function. X y horizontal line y equals 2x. 1 2 3 4 5. 1 2 3 4 5. 4 3 2 1 1 2 3 4 5. Crossing point x y equals x2. 1 2 3 4 5. 1 2 3 4 5. 4 3 2 1 1 2 3. Horizontal line. Crossing point. Figure 1.16 graph of fxx 2 equals figure 1.17 graph of 2fxx equals. Unit 1 further on relations and functions. 23. Example 4 using the horizontal line test, show that f rightward arrow given by f x equals x2 is not 1 to 1. Solution: a horizontal line crosses the graph of y equals x2 at 2 points, figure 1.17. Thus, f is not 1 to 1. Example 5. Which of the following are one-to-one functions? F equals x, y is the father of x. H equals x, y equals x2. CG equals x, X is a dog and Y is its nose. Solution only G is one-to-one. Exercise 1.8. Exercise 1.8. 1. Which of the following functions are one-to-one? F equals 1, 5, 2, 6, 3, 7, 4, 8. F equals 2, 2, 1, 3, 0, 1, 4, 1, 5, 6. F equals x, X is a brother of DG equals x, y, xy is a child and is his/her age. Rightward arrow, x equals 3x, 2. FH, 0, infinity, rightward arrow, x equals 5 log x. GF, rightward arrow, given by f, x equals x1. 2. Let A, B, C, D be constants with add, BC is not equal to 0, and x plus b fx cx plus d equals. Check whether or not f is one-to-one. 1.3.2 Onto functions. Definition 1.9. A function f, a rightward arrow b is onto, a surjection, if and only if, range of f equals b. Example 6. Let f be defined by the Venn diagram in figure 1.18 below. Range of f equals b. Therefore, f is onto. Mathematics grade 11. 24. 4321 AB. C. F. AB. ABCD. 1 2 3 4 5 F. AB. Figure 1.18. Figure 1.19. Example 7. In figure 1.19 above, range of f equals 1, 2, 4. Range of f is not equal to, thus, f is not onto. Note, let f, a b rightward arrow be a function. Range of f equals b means for any y set membership symbol b, there is x set membership symbol a, such that y equals f, x. So, to show f is onto, if possible, show that for any y, there is x set membership symbol a such that f, x, equals y. To show f is not onto, find y set membership symbol b that is not an image of any of the elements of A. Example 8. Let f, rightward arrow BF, x, equals x2 take y equals 4. Since for any x set membership symbol, 2x0, 4 greater than or equal to is not equal to. Thus f is not onto. B let f, 0, rightward arrow infinity be given by f, x, equals x2. Take y set membership symbol infinity 0, since y greater than or equal to 0, for all x set membership symbol, 2x set membership symbol infinity 0. Thus, x2 equals y has a solution. Indeed, if xy equals, then f, x, equals f, 2y equals thus, f is onto. Definition 1.10 A function f, a b rightward arrow is a one-to-one correspondence, a bijection, if and only if, f is one-to-one and onto. Unit 1 Further on relations and functions. 25. Example 9 Let f, rightward arrow be given by f, x, equals 5x, 7. Show that f is a one-to-one correspondence. Solution Let x1, x2 set membership symbol, such that f, x1, equals f, x2, 5x1, 7 equals 5x2, 7 5x1, 7 plus 7 equals 5x2, 7 plus 7 5x1 equals 5x2 x1 equals x2 so, f is one-to-one. Let y set membership symbol. Is there x set membership symbol such that y equals f, x? If there is, it can be found by solving y equals f, x, equals 5x, 7. Y plus 7 equals 5x plus 7 equals 5yx. So for any y set membership symbol, take x equals 7 5y plus set membership symbol. Then plus 7 equals 5 7 5 5y fx fy equals. So f is onto. Therefore, f is a one-to-one correspondence. Example 10 Check if the following function is a one-to-one correspondence. A B C D E 1 2 3 4 F A B Figure 1.20 Solution f is onto, because range of f equals 1, 2, 3, 4 equals b. But f is not one-to-one, because f, d, equals f, e, equals 4, while d is not equal to e. So, f is not a one-to-one correspondence. Mathematics Grade 11. 26. Example 11. Let f rightward arrow be given by f x equals 3x. Check whether or not f is a one-to-one correspondence. Solution for any x1, x2 set membership symbol 1212 33x x f x f x equals 112230131333 x x x equals 120 x equals 12 x equals x. Thus f is 1-to-1. But f is not onto, because negative numbers cannot be images. For instance, take y equals 4. Since 3x greater than 0, for every x set membership symbol, it is not possible to have x set membership symbol, for which 4 x equals. Thus, f is not onto, therefore, f is not a one-to-one correspondence. Exercise 1.9. Exercise 1.9. 1. Which of the following functions are onto? F rightward arrow f x equals 3x plus 5bg 0 infinity rightward arrow equals 3g xxc. AB CD 1 2 3. F Figure 1.21 df rightward arrow f x equals x3. Rightward arrow h x equals x12. For each of the following functions, give the set B, for which f rightward arrow bis onto. AF x equals x2 plus 2bf x equals x plus 5. CFXX equals 3DFXX 1 3 equals. Unit 1. Further on relations and functions. 27. 3. Show whether each of the following functions is a one-to-one correspondence or not. AF rightward arrow 3 plus 1 equals 5xfx. BGGXX 0 infinity rightward arrow infinity equals CH rightward arrow 0 equals 5x infinity HXD2FFXX1 0 1 1 infinity rightward arrow infinity equals plus 4. Find a one-to-one correspondence between the following pairs of sets AA and B1 2 3 equals ABCBA1 2 3 50 B1 2 3 50 equals CA equals N and B 5 8 11 equals 1.4 Composition of functions. Combination of functions. Note: recall the following. Let f and g be two functions. Then, f plus g x equals f x plus g x f g x equals f x g x f g x equals f x g x f g x equals f x g x, where g x is not equal to 0. Domain of f plus g equals domain of f g equals domain of f g equals domain of f domain of g. Domain of f g equals domain of f domain of g backslash x g x equals 0. Definition 1.11 Let f a b g b c and rightward arrow be functions. Then, the composition of g by f, denoted by gof, is given as gof x equals g f x. Mathematics grade 11. 28. Example 1. Given the Venn diagram in figure 1.22, find a gof a b gof d ab cd 1 2 3 f e f g h g. Figure 1.22 Solution: gof a equals g f a equals g 1 equals e and gof d equals g f d equals g 3 equals h. Example 2. Given the Venn diagram in figure 1.23, find a gof b b gof c ab cd 1 2 3 f e f g h g. Figure 1.23 Solution: gof b equals g f b equals g 1 equals e and gof c equals g f c equals g 2 equals g. Example 3. Let f x equals 2x plus 1 g x equals x3. Give fog x and gof x. Solution: fog x equals f x3 equals 2x3 plus 1, while gof x equals g 2x plus 1 equals 2x plus 1, 3. Example 4. Give fog x gof x fof x gog x if they exist, for f x equals 5 log x, g x equals x2 plus 2. Solution range of f equals domain of g equals gof x exists and gof x equals 255 gxx log equals log plus 2. Range of g equals 2. Infinity domain of f equals 0, infinity, and hence domain of f range of g is not equal to fog exists and fog x equals 25 log plus 2 x. Unit 1 further on relations and functions. 29. Fof x equals 555 log fxx equals can be defined only if 5 log 0 x, i.e. if and only if x greater than 1. Gog x equals 222 gxx plus 2 equals plus 2 plus 2. Here x can be any real number. Activity 1.11. 1. Let f x equals x plus 1 and g x equals x. A. Give fog and gof. B. Find the I domain of fog, 2 domain of gof. 3. Range of fog, 4 range of gof. 2. Let f x equals x2 1 and g x equals x. A. Give fog gof. B. What is the domain of gof? C. Sketch the graph of gof. 3. Let f x equals 2 log and x g x x equals. A. Give fog and gof. B. Give the domain of fog and the domain of gof. C. Sketch the graph of both the functions fog and gof. Example 5. Let f rightward arrow infinity 0 be given by f x equals 2x and g 0 infinity rightward arrow infinity be given by gxx equals. Then find gof x and the domain of gof x. Solution: gof x equals 2 x x g equals. Domain of gof equals domain of f equals. Example 6. Let f x equals 5x plus 4 and gof x equals 7x 1. Find g x. Solution: since gof and f are linear, try a linear function g x equals x plus b. G f x gx equals 5 plus 4 equals A, 5x plus 4, plus B equals 5x plus 4A plus B. Now, g(f(x)(x), 7 1 equals 5x plus 4a plus b equals 7x, 1 5a equals 7a equals 7 5 and 4a plus b equals 1b equals 1, 4ab equals 128 33 equals 5 5. Thus, 733, 55 gxx equals. Mathematics Grade 11. 30. Exercise 1.10 Exercise 1.10 1 Let f x equals 9x 2 and gxx 3 plus 7 equals. Evaluate the following: ag 3, g 2, b g 1, 2 c f x f 0 x 2 Let f x equals 9x 2 g x equals 3 plus 7x. Find each of the following: a f plus g 2 b 7 f g c domain of f plus g, D domain of Fg E domain of Fg. 3 Find f plus g x f g x fg x and fxg. For the following: af x equals 521xx 6 equals 21xgxxbf x equals x plus 1 1 equals 1gxx plus 4 Let f x equals 3x 2 g x equals 5x plus 1. Compute the indicated values. A 3 fog b fof 0 c gof 5 d gog 7 e fogof 2 5 Find I fog x2 gof x3 fof x4 gog x if they exist. 4 af x equals 2x 1 g x equals 4x plus 2 bf x equals x2 g x equals xcf x equals 1 5x g x equals 2 plus 3x df x equals 3x g x equals 2x. 6 Let f x equals 3x g x equals xhxx and equals. Express each function below as a composition of any two of the above functions. ALXX 3 equals BKXX 3 equals CT x equals x7. Express each function f as a composite of two simpler functions h and g, i.e. f equals hog afxx equals 3 plus 1 bf x equals 16x2 3c2 3 plus 1 equals 2xfx df x equals 5 times 2 2x plus 3e4 2fxxx equals 6 plus 6 8. Let f x equals 4x plus 1 and g x equals 3x plus k. Find the value of k for which fog x equals gof x. 9. If f x equals x plus b, a is not equal to 0, find g such that gof x equals x. 10. Given f x equals x4 and g x equals 2x plus 3, show that fog x is not equal to gof x in general. Unit 1. Further on relations and functions. 31. 1.5 Inverse functions and their graphs. Activity 1.12. Give the inverses of each of the following. AF equals 3 4x yx equals. Is f1 a function? BR 3 4 equals greater than or equal to x yx. Is R1 a function? CF equals x y equals x2. Is f1 a function? DG equals x y equals 2 log x. Is g1 a function? From your investigation, you should have noticed that. Note: f1 is a function if and only if f is 1 to 1. Example 1 is the inverse of f x equals x3 x plus 1 a function. Solution domain of f equals n for 1 set membership symbol domain of f 1 equals 1 to 1 plus 1 equals 1 equals f1. This implies f is not 1 to 1. Therefore f1 is not a function. Notation: if the inverse of f is g, then g is denoted by f1. In this case f is called invertible. Steps to find the inverse of a function f. 1. Interchange x and y in the formula of f. 2. Solve for y in terms of x. 3. Write y equals f1 x. Example 2. Find the inverse of each of the following functions. AF x equals 4x 3. BF x equals 1, 3xcf x equals 1, 1x is not equal to. Solution: AF equals 4, 3xyx and F1 equals 4, 3xyxy equals 3, 4xxyy plus equals 1 plus 3 equals 4xfx. Mathematics grade 11. 32. BF equals x, y equals 1, 3x. F1 equals x, yx equals 1, 3y equals 1. 3. xxyy equals. Therefore F1 x equals 1. 3. X CF equals x, y equals 1, 1. X is not equal to. F1 equals x, yx equals 1, 1. Yx. Y is not equal to. Equals x, yx, y, 1, equals y, x is not equal to 1. Equals x, y, x, 1, equals x, x is not equal to 1. Equals x, y equals 1, 1. X is not equal to. Definition 1.12. The function IAA, rightward arrow given by I, x, equals x is called the identity function. Note: if f a rightward arrow a, and I a rightward arrow a, then I of x equals ifx fxx for every a equals set membership symbol. Again, foi x equals fix fxx for every a equals set membership symbol. We can define the inverse of a function using the composition of functions as follows. Definition 1.13. A function g is said to be an inverse of a function f, if and only if g f(x(x) f g x(x) equals I, and equals I. Example 3 show whether or not each of the following pairs of functions are inverses of each other. AF, rightward arrow infinity, 0, given by, equals 2x fx and g, 0, infinity, rightward arrow given by g, x, equals 2 log x. BF, x, equals 1, 2, 2. X plus and g, x, equals 1 2, 1 1. X is not equal to CF x equals 5, 1 1. X plus is not equal to plus, and 5 equals 2 1. XGXXX is not equal to plus. Unit 1 further on relations and functions. 33. Solution. A. Fog x equals 2 log 2 and log 2 x equals x gof x ix. Thus f and g are inverses of each other, i.e. g equals f1 or f equals g1. b1 2 equals I 1. XFG XFXXX and G F X equals G plus 1 plus 2XX equals X equals I X. Thus f and g are inverses of each other, i.e. g equals f1 or f equals g1. C5 4 plus 15 equals I 2 7. XXFG XFXX is not equal to plus, and 5 4 equals I 1 3 plus 7. XXGFXGXXX plus is not equal to plus. Hence f and g are not inverses of each other. Activity 1.13. Recall that the graph of the inverse of a relation is obtained by reflecting the graph of the relation with respect to the line y equals x. For each of the following, sketch the graph of f and f1 using the same coordinate axes. AF x equals 2x plus 3bf x equals x3. From activity 1.14, you may have observed that the graph of f1 can be obtained by reflecting the graph of f with respect to the line y equals x. Exercise 1.11 Exercise 1.11 1. Determine the inverse of each of the following functions. Is the inverse of function AF x equals 3 log 2x bh x equals 5x plus 13. CGXX 1 equals plus D2KXX 2 equals 2. Give the domain of each inverse in question 1 above. 3. Are the following functions inverses of each other in their respective domain? AF x equals 3x plus 2 2 3x gx equals b3 3f x gxx equals c2f x gxx equals d3 3f x gxx 8 and 8 equals plus equals. For which of the following functions are invertible? If they are not, can you restrict the domain to make them invertible? A 3fxx equals b2gxx 4 equals c1 5 3hxx equals plus d2fxx log equals. Mathematics grade 11. 34. 5. Which of the following functions are invertible? Y x y x y x. ABC figure 1.246 sketch F1 for each of the following functions. Y x y x y x. ABC figure 1.25 key terms. Combination of functions modulus, absolute value, composite function 1-to-1 correspondence cusp 1-to-1 function domain onto function parity greatest integer, floor, function power function horizontal line test range identity function relation inflection point signum, SGN, function inverse function vertical line test. Unit 1 further on relations and functions. 35. Summary. 1. A relation from A to B is any subset of A times B. 2. F plus or minus G, X, equals F, X, plus or minus G, X, FG, X, equals F, X, G, X, FFXX equals GGX. Provided that G, X, is not equal to 0. 3R1 equals B, A, B, set membership symbol R. For domain of R, 1 equals range of R and range of R, 1 equals domain of R. 5. A function is a relation in which no two of the ordered pairs in it have the same first element. 6. F x equals XR. Our set membership symbol is called a power function. 7. F x equals MNX. M even and N odd has a cusp at the origin. 8x equals 4 for x, x0. X greater than or equal to 9x equals 2x. 10 SGNX equals 1, 4 0, 4 1, 4. X0 x equals 0x. 11. The floor function or the greatest integer function f x equals x maps into z. 12. F is 1 to 1, if and only if f x1 equals f x2, x1 equals x2, for any x1, x2 set membership symbol domain of f. 13. A numerical function f is 1 to 1, if and only if no horizontal line crosses the graph of f more than once. 14. F. A rightward arrow b is onto, if and only if range of f equals b. 15. F. A rightward arrow b is a 1-to-1 correspondence, if and only if f is 1 to 1 and onto. 16. Fog x equals f g x. 17. Domain of fog subset symbol domain of g. 18. F1 is a function, if f is 1 to 1. 19. G and f are inverse functions of each other, if and only if g, f, x, equals x and f, g, x, equals x. 20. To find f1. Write y equals f, x. Interchange x and y in the above equation to obtain x equals f, y. Solve for y and write y equals f1, x. Mathematics grade 11. 36. Review exercises on Unit 1. 1. Find the inverse of each relation and determine whether the inverse is a function. AR equals 2, 2, 3, 3, 4, 4. BR equals 2, 1, 2, 3, 2, 7. To find the inverse of each function. Is the inverse of function AF x equals 2x plus 3bf x equals x2, 9. CF x equals x2, 9. 2d, 3x fx equals 3. Find the domain of fxxx equals 4. Give the intersection points of y equals x5 and y equals x7. B. Are these points common to y equals xn, where n is an odd natural number? C. For each of the following functions, what is the effect of 4, when f x is compared with y equals x3? If x equals 4x3 2f x equals x3 plus 4d for f x equals x3. Compare f ab and f a f b. For any a b set membership symbol, what do you notice? E is the property f ab equals f a f b. For any A, B set membership symbol are generally true for any F, X, equals XN, and set membership symbol. 5. Draw the graph of Y equals F, X, using the graph of Y equals F, X, for each of the following: AF, X, equals X plus 1 BF, X, equals log XCF, X, equals X 6. Show that Y equals SGN X is odd. B. If H, X, equals 1 2, SGN X plus 1, show that H, X, plus H, X, equals 1. C. Express H, X, in terms of X, by taking X0, X equals 0 and X. 8. Check if 1 2 equals plus 2xxx, by taking different values of X. 9. Find fog, FOF, GOF, GOG for AF, X, equals 1 plus 2x, G, X, equals XBF, X, equals log X, G, X, equals 3x plus 110. What is the domain of each composite function in question 9? 11. Determine whether or not each pair of functions are inverses of each other. AF, X, equals 2x, 4, equals 2xg x plus bf, x, equals 2x plus 5, 5, 2xg x equals. Unit outcomes. After completing this unit, you should be able to know methods and procedures in simplifying rational expressions. Understand and develop efficient methods in solving rational equations and inequalities. Know basic concepts and specific facts about rational functions. Main contents. 2.1 Simplification of rational expressions. 2.2 Rational equations. 2.3 Rational functions and their graphs. Key terms. Summary review exercises. Rational expressions and rational functions. Unit 2x y 1 2 3 4 5 1 2 3 4 5 4 3 2 1 1 2 3 4 5 5 Mathematics Grade 11 38 Introduction. We now turn our attention to fractional forms. A quotient of two algebraic expressions, division by zero excluded, is called a fractional expression. If both the numerator and denominator are polynomials, the fractional expression is called a rational expression. Just as rational numbers are defined in terms of quotients of integers, Rational expressions are defined in terms of quotients of polynomials. Historykalnudi. John Bernoulli, 1667 to 1748. The method of partial fractions was introduced by John Bernoulli, a Swiss mathematician who was instrumental in the early developments of calculus. John Bernoulli was a professor at the University of Basel and taught many outstanding students, the most famous of whom was Leonhard Euler. OpenING Prob Lem. Abera, working alone, can paint a small house in 6 hours. Janet can paint the same house in 12 hours. If they work together, how long will it take them to paint the house? 2.1 Simplification of rational expressions. Activity 2.1. Determine the domain, or universal set, of each of the following expressions. ax2 plus 3x, 4b log, x plus 2, c1 5x d3 5x x plus. Unit 2 Rational expressions and rational functions. 39. 2.1.1 Rational expressions. Definition 2.1. A rational expression is the quotient px/qx of two polynomials px and qx, where qx is not equal to 0. Px is called the numerator and qx is called the denominator. Some examples of rational expressions are the following. Recall, a non-zero constant is a polynomial of degree 0. Example 1. Which of the following are rational expressions? A 2 2 2 3 4 x x x plus b 4 1. x1 c4 3 6 3 x plus x d1 5x. Solution: all except D are rational expressions. Example 2. Evaluate the rational expression 3925 plus x for the given values of x. Ax equals 5, bx equals 6. Solution: at x equals 5, 3925 plus x 24 5 15 9 10 5 5 39 5 2 5 equals plus b at x equals 6, 3925 plus x 9 17 9 17 18 9 12 5 3 6 9 2 6 5 equals plus. Domain of a rational expression. Activity 2.2. Do the following activities. Find the domain of x 5 to 2 plus. B. Factorize the numerator and denominator of x 5 to 2 plus. C. Simplify x 522 plus D. When R225 plus and its simplified form equal. E. Do steps A, D for the rational expression 9 9 10 9 4 2 2 plus x. Mathematics grade 11. 40. Note: in example 2 above, since the denominator 3x plus 9 equals 0, 4x equals 3, 2539x plus is undefined. When x equals 3, therefore, the domain of 2539x plus is x is a real number and x is not equal to 3. Steps to find the domain of a rational expression: 1. Set the denominator of the expression equal to 0 and solve. 2. The domain is the set of all real numbers except those values found in step 1. Example 3. Find the domain of each of the following rational expressions: a 3x 19b 7 10 9 2 2 plus x. Solution is set the denominator equal to 0 and solve. 3x equals 0, x equals 0. Thus, the domain is x. X is a real number and x is not equal to 0 or \0. B. Set the denominator equal to 0 and solve. 7 10 0 2x plus equals x, 5x, 2 equals 0. x5 equals 0 or x2 equals 0. X equals 5 or x equals 2. Factor: set each factor equal to 0 and solve. Thus, the domain is x. X is a real number and x is not equal to 2. X is not equal to 5 equals \2, 5. Fundamental property of fractions. If a, b and k are real numbers with b, k is not equal to 0, then ca kbb equals. Note: using the above property and eliminating all common factors from the numerator and denominator of a given fraction is referred to as reducing, or simplifying, the fraction to its lowest term. Definition 2.2 We say that a rational expression is reduced to lowest terms, or in its lowest terms or in simplest form, if the numerator and denominator do not have any common factor other than 1. Unit 2 Rational expressions and rational functions. 41. Note: it is important to emphasize that 2294910xx plus equals 3235xx plus only if 53x is not equal to and 23x is not equal to. Though 3235xx++ is undefined at 53x equals only, the original expression 2294910xxx+ is undefined at 53x equals and 23x equals. We are only allowed to reduce 3232xx to 1, provided that 3x, 2 is not equal to 0. To simplify a rational expression, 1. Find the domain. 2. Factorize the numerator and denominator completely. 3. Divide the numerator and denominator by any common factor, i.e. cancel like terms. Example 4. Simplify the following. Of 4, 12, 16, 2, 6, 4, 2, 2. Plus y. B9 18 80 1 2 4 2 plus xxx. C7 7 1 2 AA. Solution. The universal set is \1, 4. Thus, 2, 4 2, 4, 4, 1, 2, 2, 1 4 12 16 2 6 4 2 2. Plus equals plus equals. Plus y, for y is not equal to 4 and y is not equal to 1. B9 9 18 80 1 2 2 2 2 2 4 2 equals plus equals plus xxxxxx for all x set membership symbol. C 7 1 1 7 1 1 1 7 1 1 7 7 1 2 2 plus equals a for a set membership symbol \1 1. Exercise 2.1 Exercise 2.1. State the domain and simplify each of the following. AX 4 4 12 B 2 5 12 6 23 22 2 plus XXXX C 3 3 2 plus XXX D3 27 81 27 433 plus XXXXEXXXX 32856 plus FXXXXX 3288324. Mathematics Grade 11. 42. 2.1.2 Operations with rational expressions. Activity 2.3. Do the following in groups. Perform the following operations on rational numbers. A 5788 plus B3 546 plus C11 412 12 D7 210 5. Note. Rational expressions obey the same rules as rational numbers, for addition, subtraction, multiplication, and division. Addition and subtraction of rational expressions. Let Px, Qx, and Rx be polynomials such that Qx 0 is not equal to, then Px plus Rx plus equals Qx and Px Qx equals. Example 5. For each rational expression, state the universal set and simplify. A 1515 plus x b 69669232 plus x. C4274313 plus AAAAD 71287121222 plus AAAAA. Solution. A 121 5 51515 plus equals x for x is not equal to 1. B69396992 3 66966923222 plus equals xxxxxxxxxxxxxxxxxxx for x is not equal to 3. C4643 13 2 7427413 plus equals AAAAAAAAAAAA for A is not equal to 4. D222222218 1 89712712712 equals AAAAAAAAAAAAAA 3 3 3 3 4 AAAAAA plus equals for A is not equal to 3 and 4. Unit 2 Rational expressions and rational functions. 43. Exercise 2.2 Exercise 2.2. Perform the indicated operations and simplify. AXXXXX53552322 plus B2152122153222 plus XXXXXXX CXXX52512 plus D412744412761122 plus YYYYYY. Activity 2.4. Do the following activities. Factorize the denominators and find the domain of 11242942 plus XXXXX. B. What is the least common multiple of the denominators? C. Apply the rule for addition of rational numbers to express 11 24 29 422 plus x x x x x in the form pxqx. D. Simplify your result. Steps to add and subtract rational expressions with unlike denominators. Unlike denominators. 1. Factorize the denominators completely. 2. Find the LCM. 3. Build each rational expression into an equivalent expression with the denominator equal to the LCM. 4. Add and subtract the numerators and write the result over the common denominator. 5. Simplify the numerator and factorize it to see if you can reduce it. Example 6. Perform the indicated operations and simplify. Of 4336232 plus YYYB 2325212132 plus CCCC. Solution. We first find the LCM by factorizing each denominator. 3 3 2 2 2 2 3 3 1 3 2 2 3 2 2 3 2 2 y y y y y y y y y y plus. Mathematics grade 11. 44. 9 2 2 2 2 3 3 3 2 2 y y y y y y plus equals plus 22293624399549 4y minus 2 and 2 3 2 2 3 12 y y y y y y y y plus equals is not equal to plus b. Notice that 2c2 plus 3c 2 equals 2c 1 c plus 2. Thus, the LCM is 2c 1 c plus 2 and 2 1 2 5 2 1 2 1 3 2 3 2 5 2 1 2 1 3 2 plus equals plus c 2 1 2 5 2 1 2 2 1 2 1 2 3 2 plus equals c 3 2 2 1 5 2 1 2 1 2 2 1 2 2 1 c plus equals plus 4c is not equal to 2 and 1. 2. Exercise 2.3 Exercise 2.3. Perform the indicated operations and simplify. AYYY 4 5 16 5 4 25 2 plus BXX plus X plus 2 2 1 1 C 1 1 1 plus UU D 2 2 2 3 4 of B plus E 2 3 2 2 2 plus X X X X F 1 2 1 2 plus X plus XX G3 1 25 15 5 2 25 15 2 50 55 8 2 2 2 plus X X X X X X X X X H3 12 2 4 6 plus Z. Activity 2.5. Do the following in groups. 1. Perform the following operations on rational numbers. A 3375 times B5 22 11 45 times C4 96 12 divided by D7 35 46 divided by 2. What are the rules used to simplify the expressions? Multiplication of rational expressions. If P, X, Q, X, R, X, and S, X, are polynomials such that Qx, 0 is not equal to Sx, 0, is not equal to then Px are X, Px are X, Qx, Sx, Qx, Sx equals Unit 2 Rational expressions and rational functions. 45. Steps to multiply rational expressions. 1. Factorize the numerators and denominators completely. 2. Divide out all the common factors. 3. Multiply numerator with numerator and denominator with denominator to get the answer. Example 7. Evaluate and simplify. A 1442552 plus x x x x x b 4821025 422 plus x x x x x. Solution. By first factorizing the numerators and denominators, we get 2255445 1 2 2 5 2 2 1 2 1 1 1 x x x x x x x x x x x x x plus equals plus 4x is not equal to 1 1 and 2. B. Factorizing the numerator and denominator yields 5 1 4 2 2 5 5 4 5 4 8 2 10 25 4 22 plus equals plus equals plus x x x x x x x x x x 4x is not equal to 5 and 2. Division of rational expressions. If P, X, Q, X, R, X, and S, X, are polynomials such that Rx, 0 is not equal to qx, 0 is not equal to sx, 0 is not equal to then px rx px sx px sx qx sx qx rx qx rx divided by equals. Example 8. Perform the following operations and simplify. A 2, 7, 15, 4, 12, 9, 3, 13, 10, 36, 48, 16, 2, 2, 2, 2. Plus divided by plus x x x x x x x x ba divided by. Solution. First, you have to invert the second fraction and multiply. Then factorize each expression and simplify. 2 2 2 2 36 48 16 2 7 15 3 13 10 4 12 9 x x x x x x x x plus times plus 4 3 2 3 2 2 3 5 3 2 5 2 3 2 3 x x x x x x x x plus equals times plus 4 3 2 2 3 x x equals 4x is not equal to 5 2 3 and 3 2. B. First, invert the second fraction and multiply. A b divided by equals times equals. 4a is not equal to b and b is not equal to 0. Mathematics grade 11. 46. Exercise 2.4. Exercise 2.4. 1. Evaluate and simplify each of the following expressions. State their domains. A 2 2 12 3 9 4 x x x x x plus times b 3 2 2 27 3 9 3 9 x x x x x plus times plus 2. Perform the indicated operations and simplify. A 2 2 7 12 5 4 9 x x x x plus times b 2 2 5 2 1 2 3 2 2 2 2 2 plus divided by x x x x x x x. C x x x x x x divided by 2 3 3 12 6 2 2 2. 2.1.3 Decomposition of rational expressions into partial fractions. So far, you have been combining rational expressions using addition, multiplication, subtraction, and division rules. Next, you will consider the reverse process, decomposing a rational expression into simpler ones. We obtain the sum of fractions 2x and 3x plus as follows. 1322 plus x equals 2154. Plus x equals 2542 xxx. The reverse process of writing 2542xxx as a sum or difference of simple fractions. Fractions with numerators of lesser degree than their denominators is frequently important in calculus. Each such simple fraction is called a partial fraction, and the process itself is called decomposition into partial fractions. Definition 2.3. In a rational expression, px/qx, if the degree of px is less than that of qx, then px/qx is called a proper rational expression. Otherwise it is called improper. From your previous knowledge of algebra, you know that any rational expression can be written as the sum of a polynomial and a proper rational expression. Unit 2 Rational expressions and rational functions. 47. To decompose a rational expression, px/qx, the degree of px must be less than the degree of qx. In a case where the degree of px is greater than or equal to the degree of qx, you have only to divide px by qx to obtain px rx sx qx qx equals plus where the degree of rx is less than that of qx. The decomposition is then done on rx qx. Example 9 Express 3221013xxxx++ as a sum of a polynomial and a proper rational fraction. Solution using long division. 2x3 plus 10x2, 3x plus 1 equals x plus 3, 2x2 plus 4x, 15, plus 46. Thus, 3 2 2 10 3 1 46 2, 2 4 15, 3 3 plus plus equals plus 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 x x x x x x x. Moreover, you need to rely on the following definition to do the partial fraction decomposition. Definition 2.4. Two polynomials of equal degree are equal to each other, if and only if the coefficients of terms of like degree are equal. Activity 2.6. 1. Factorize x3 3x2 plus 2x2. Factorize each of the following, if factorizable. ax2, 6x plus 9b 15x2 plus 14x 8cx2, x plus 2. 3. For each of the quadratic polynomials x2 plus bx plus c in question 2 above, find b2, for ac. Which quadratic polynomial cannot be factorized further? Can we use the sign of b2, for AC to decide which quadratic polynomials can be factorized? 4 factorize x4 plus 7x3 plus 12x2 7x13. Note: x2 plus bx plus c is not reducible in real numbers, if b2, 4ac. Mathematics Grade 11. 48. Theorem 2.1 Linear and Quadratic Factor Theorem. For a polynomial with real coefficients, there always exists a complete factorization involving only linear and or quadratic factors, raised to some power of natural number k greater than or equal to 1, with real coefficients, where the linear and quadratic factors are not reducible relative to real numbers. So, once you have decided that partial fraction decomposition is to be done for a rational expression, you factorize the denominator as completely as possible. Then, for each factor in the denominator, you can use the following table to determine the term s you pick up in the partial fraction decomposition. The table gives the various cases that can arise. Factor in the denominator corresponding term in the partial fraction. 1x plus b ax b plus, a constant. 2, k ax b plus 1 2 2, k k ax b plus 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 plus. 1 2, k are constants. 3 2 x c plus plus, with b2 4ac. Plus 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 2. A, b are constants. 4 2, k x c plus plus, with b2 4ac. 1 1 2 2 2 2 2 2, k ax b axbxc plus 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 plus. 1 2 1 2, b are constants. Example 10. Decompose each of the following rational expressions into partial fractions. A 2 3 5 7 2 plus x b 2 2 2 3 6 14 27 plus x c 2 1 5 8 5 2 2 plus x d 2 2 3 2 2 3 4 9 5 plus x e 1 2 3 x plus x. Solution. The denominator x2 plus 2x 3 equals x 1 x plus 3. The two factors x 1 and x plus 3 are distinct. Thus, we apply part 1 of the table to get 1, 3 1 3 5 7 2 3 5 7 2 plus equals plus x b x a x x x x x x. To find the constants a and b, we combine the fractions on the right side of the above equation to obtain Unit 2 rational expressions and rational functions. 49. 1, 3, 3, 1, 1, 3 5 7. Plus equals plus xx ax bx xxx. Since these expressions have the same denominator, their numerators must be equal. Thus 5x plus 7 equals a, x plus 3 plus b, x, 1 equals a plus b, x plus 3ab. Using definition 2.4, we have a plus b equals 5 and 3 7, ab equals which gives a equals 3 and b equals 2. Hence, 3 2 1 3 2 3. 5 7 2 plus equals plus xxxxx. This can easily be checked by adding the two fractions on the right. By using parts 1 and 2 of the table, we write 2 2 2 6 14 27, 2, 3, 2 3, 3, x x a b c. X x x x x equals plus 2 2, 3, 2, 3, 2, 2, 3, ax b x x c x. X x plus equals plus thus 6 14 27, 3, 2, 3, 2 2 2 x x equals a x plus b x plus c x plus which holds for all x. In particular, if x equals 3, then equals 15 5, c which gives c equals 3 and if x equals 2, then 25 25 equals a which gives a equals 1. There are no other values of x that will cause terms on the right to be equal to 0. Since any value of x can be substituted to produce an equation relating a, b, and c, we let x equals 0 and obtain 27 equals 9a 6b plus 2c, substitute a equals 1 and c equals 3. 27 equals 9 6b 6b equals 5. Thus, 2 2 2. 3 3 3 5 2 1, 2, 3 6 14 27. plus plus equals plus x x x x x x x. C for x2, x plus 1, b2, for AC equals 3. 2, 1 2 1 5 8 5 2 2 2. Plus 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 equals plus plus. X. X B X C X A. X X X X X. 2, 1, 1, 2 2 2. Plus 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 equals x x x. A x x b x c x. Thus, for all x, 5 8 5, 1, 2 2 2 x x plus equals a x x plus plus b x plus c x. If x equals 2, then 9 equals 3a, which gives a equals 3. If x equals 0, then using a equals 3, we have 5 equals 3, 2c, so that c equals 1. Mathematics grade 11. 50. If x equals 1, then using a equals 3 and c equals 1, you have b equals 2. Hence, 1 2 1 2 3, 2, 1 5 8 5 2 2 2. Plus plus equals plus plus x x x x x x x x x. D, since 232x plus cannot be factorized further in the real numbers, you proceed to use part 4 of the table, as shown below. 2222232, 2, 323, 2, 3495. Plus 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 equals plus plus x x c x dx. X x b x x x x x. 2 2 2, 2, 3, 2, 3. Plus 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 equals x x. X b x x c x d. Thus, for all x, x for x plus 9x5 equals x plus b, x2x plus 3 plus cx plus d 3 2 2. 2, 3, 2, 3. 3 2 equals x plus b a x plus a b plus c x plus b plus d. Equating coefficients of terms of like degree, we obtain a equals 1, b2a equals 4, 3a2b plus c equals 9 and 3b plus d equals 5. From these equations we find that a equals 1, b equals 2, c equals 2 and d equals 1. Now you can write 2 2 2 2 2 3 2, 2, 3 2 1 2 3 2, 2, 3 4 9 5. Plus 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 equals plus plus x x x x x x x x x x x. This is not a proper rational expression. Note that 1, 2322x plus equals x plus x plus. Divide 3x by 322x plus x plus. It gives a quotient x3 and remainder 7x plus 0.6. Therefore, 1, 2, 7, 6, 3, 1, 2, 3. Plus equals plus x x x x x x x. Now using the usual method, 7 6 1 8, 1, 2, 1 2 x x x x x plus equals plus. Hence, 3 1 8, 3, 1, 2, 1 2 x x x x x x equals plus. Exercise 2.5 Exercise 2.5. Write each of the following rational expressions in partial fractions. A 6762 plus x x x b 1, 2572 plus x x x x c 2, 235 plus x x. D 1, 3, 322. Plus x x x e 2432 x x x plus f 227 11 6, 1, 232, plus x x x x x. Unit 2 Rational expressions and rational functions. 51. 2.2 Rational equations. You already know how to solve linear and quadratic equations. In this subunit, you will discuss the solution of rational equations. Activity 2.7. State the universal set and solve each of the following equations. A 332x equals bx plus 2 to 3, x, 2, equals 0. C2433 plus equals x d2, 10x plus 3, equals 5x plus 6. The staff members of a school agreed to contribute 200 baht each to make up a fund to help needy students in the school. Since then, 2 new members have joined the staff, and as a result, each member's share has been reduced by 5 baht. How many members are now on the staff? Definition 2.5. A rational equation is an equation that can be reduced to the form 0 pxqx equals where p, x, and q, x, are polynomials and q, x, is not equal to 0. Note, to solve a rational equation, you can multiply both sides of the equation by the LCM of the denominators for those values of the variable for which the LCM is non-zero. An important thing to keep in mind is that those values that cause the denominator to become zero cannot be solutions to the equation. A number that looks to be a solution but causes the denominator of the original equation to become zero is called an extraneous solution. To solve rational equations, you follow the following steps. 1. Factorize all the denominators and determine their LCM. 2. Restrict the values of the variable that make the LCM equal to 0. 3. Multiply both sides of the rational equation by the LCM and simplify. 4. Solve the resulting equation. 5. Check the answers against the restricted values in step 2. Any such value must be excluded from the solution. Mathematics Grade 11. 52. Example 1. Solve each of the following equations. A 2 3 1 2 equals x plus xb 16 16 4 4 4 2 2 plus equals plus x x x x x. C 2 4 5 2 10 plus equals x x x x d 1 1 3 2 2 4 3 3 5 2 plus equals plus 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 a. Solution. Your restrictions are x is not equal to 1 and x is not equal to 2. Now, multiply both sides of the equation by their LCM, x plus 1x, 2. 2 3 1 2 equals x plus x plus equals plus 1 1 2 2 3 1 1 2 1 2 x x x x x x 2x 2 equals 3x plus 1x equals 7. This does not contradict our restrictions that x is not equal to 1 and x is not equal to 2. Thus, our solution set is 7. B. Your restrictions are x is not equal to 4 and x is not equal to 4. Now multiply both sides by the LCM, x, 4x plus 4, which will get rid of the denominators. 2x x x x, 4, 4, 4, 16 plus equals plus 8 16 16 2 2x x equals x plus equals 8 32 x equals 4. This is against our restriction x is not equal to 4, and must be excluded from our solution. Since there are no other values in our solution, the solution is C. The LCM here will be x, 2, and x cannot be 0 or 2. Multiplying both sides of the equation by this denominator equals plus 1, 2 2 5 1 4, 2 1, 2, 2 10 x x x x x x x x x x 10 4, 2, 5 10 4 8 5 4 2 5 2 x x x x x x x plus equals but x equals 2 is not allowed. Thus, the solution set is D since 2a plus equals 4 3 1. The LCM is 3 1 a where a cannot be 3 or 1. Now you can multiply both sides by the LCM. 3 5 3 1 2 2 3 1 1 3 1 3 1 1 3 1 1 1 a plus equals 3 5 2 2 1 1 3 a plus equals. When simplified, this gives 2a plus equals 5 0 or a plus 5 equals 0. Unit 2 Rational expressions and rational functions. 53. This gives us a equals 0 or a equals 5. These do not contradict our restrictions. A is not equal to 3 and a is not equal to 1. Thus, our solution set is 5 0. Example 2. One integer is 4 less than 5 times another. The sum of their reciprocals is 3 2. What are the integers? Solution: when we encounter such word problems or other real-life problems, we first assign variables to the unknowns. Now, let the unknown integers be x and y. Then one is 4 less than 5 times another can be written as x equals 5y, 4x, y integers. The sum of their reciprocals, 3 1 1 2 plus equals xy. Substituting for x, we get 3 1 2 5 4 1 plus equals yy. This rational equation reduces to the quadratic equation. 2 5 13 6 0 yy plus equals, with solutions y equals 2 and 5 3 y equals. But, since 3 5 is not an integer, the only solution for y is 2. Solving for x, we get x equals 6. Thus the required integers are 2 and 6. Exercise 2.6 Exercise 2.6 1. State the universal set and solve each of the following rational equations. Ax x 5x 1 1 2 3 equals plus d 1 6 1 3 4 2 equals plus x x x b 1 6 4 plus equals x x x x e 7 4 5 3 x 2 x equals CAAAAAA 4344122 plus equals F25 10 5 1542 equals plus XXXX. 2 planes leave an airport flying at the same rate. If the first plane flies 1.5 hours longer than the second plane and travels 2,700 miles while the second plane travels only 25 miles, for how long was each plane flying? 3. A tree casts a shadow of 34 feet at the time when a 3-foot-tall child casts a shadow of 1.7 feet. What is the height of the tree? Mathematics grade 11. 54. 2.3 Rational functions and their graphs. Activity 2.8. Identify the types, names, of each of the following functions. State their domains. AF x equals 3x plus 5bg, x equals 4, x plus 3x2. CF x equals log x plus 1, dg x equals 2 3x plus 2. EF x equals 5 cos x fg x equals 2 9x. 2.3.1 Rational functions. Definition 2.6. A rational function is a function of the form qxpxfx equals, where p, x, and q, x, are polynomials in x and q, x, is not equal to 0. Example 1. Which of the following are rational functions? A 322, 2x fxxxx equals plus b232, 1x xgx plus equals ch, x, equals 2 9x. Solution: f and g are rational functions, while h is not. 232, 1x xgx plus equals is the same as y equals 2xx plus 32, so any polynomial function is a rational function. Note: a rational function is said to be in lowest terms if p, x, and q, x, have no common factor other than 1. B. The domain of a rational function f is the set of all real numbers except the values of x that make the denominator q, x, 0. Unit 2. Rational expressions and rational functions. 55. Example 2. Give the domain of the function 2531, 2 plus equals xxxfx. Solution: the denominator 22530, 2 1, 3, 0 x x x x plus equals 1 2 x equals or x equals 3. Thus, our domain is the set of all real numbers except 1 2 and 3, because 1 2 and 3 both make the denominator equal to 0. Activity 2.9. Given the rational functions x f x1 equals n2 equals x x g x, find the following functional values and plot the corresponding points on the coordinate plane. 1af, 2 bf, 3 cf, 0.4 df, 1.5 2ag, 0 bg, 3 cg, 2 dg, 2.5 GROUPWORK2 GROUPWORK2 1. Do the following in groups. Consider the function 1f(x), x equals 1. What is its domain? 2. Fill in the following table for values of x to the left of 0. x1 0.5 0.10 0.010 0.001 rightward arrow 0. f x rightward arrow infinity b. Fill in the following table for values of x to the right of 0. x1 0.5 0.10 0.010 0.001 rightward arrow 0. f x rightward arrow infinity 3. Complete the following sentences. As x approaches 0 from the left, f x underscore 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 without bound. As x approaches 0 from the right, f x underscore 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 without bound. As x increases or decreases without bound, the values of 1f(x) equals x approach underscore underscore underscore. Mathematics grade 11. 56. 4. Here is the graph of 1f(x) equals x. X. Y. 1 2 3 4. 1 2 3 4. 3 2 1 1 2 3. 5. Figure 2.1. Do your observations correspond with the graph? Note, these two behaviors of f near x equals 0 are denoted as follows. AF x rightward arrow infinity as x rightward arrow 0. BF x rightward arrow infinity as x rightward arrow 0 plus. In this case, the line x equals 0, the y-axis, is called a vertical asymptote of the graph of f. In addition, we have CF x rightward arrow 0 as x rightward arrow, infinity df, x, rightward arrow 0 as x rightward arrow infinity. Here, the line y equals 0, the x-axis, is called a horizontal asymptote of the graph of f. Definition 2.71 The line x equals a is called a vertical asymptote of the graph of f if f, x, rightward arrow infinity or f, x, rightward arrow, infinity as x rightward arrow a, either from the left or from the right. 2. The line y equals b is called a horizontal asymptote of the graph of f if f, x, rightward arrow b as x rightward arrow infinity or as x rightward arrow infinity. Unit 2 Rational expressions and rational functions. 57. Rules for asymptotes and wholes. Once the domain is established and the restrictions are identified, here are the pertinent facts. Note: let 0, 0, n, MP x x a f x q x b x b plus plus equals plus plus be a rational function, where n is the largest exponent in the numerator and m is the largest exponent in the denominator. 1. The graph will have a vertical asymptote at x equals a if q, a, equals 0 and p, a, is not equal to 0. In case p, a, equals q, a, equals 0, the function has either a hole at x equals a or requires further simplification to decide. 2. If n, 3. If n equals m, then the line AYB equals is a horizontal asymptote. 4. If n equals m plus 1, the graph has an oblique asymptote and we can find it by long division. 5. If n m plus 1, the graph has neither an oblique nor a horizontal asymptote. Example 3. Give the vertical and horizontal asymptotes, if they exist. A 1, 2 fxx equals plus b 4 2, 2 equals xx fx. C3 2 1, 2, 2 plus plus equals xxx fx d2, 1, 1, 1, 2 xxfxxx plus equals plus plus. Solution: A, 1, 2 pxfxqxx equals plus. The domain of f is x. X is not equal to 2. Since p, 2, is not equal to 0 and q, 2, equals 0, x equals 2 is a vertical asymptote. Besides degree of p, x, b, consider the rational function 2, 2, for p xxfxqxx. equals equals. The domain of F is all real numbers except x equals 2 and x equals 2. P 2 is not equal to 0 and Q 2 equals 0. Thus, x equals 2 is a vertical asymptote. P 2 equals Q 2 equals 0. Thus, F has a hole at 1, 2, 4. Mathematics grade 11. 58. Cancelling out the common factor x, 2, we obtain 1, 2gxx equals plus, and g, 2, equals 4, 1. There n equals 1 and m equals 2. Therefore, the x-axis is a horizontal asymptote. See factorizing numerator and denominator gives 2, 2, 1, 1, 1, 3, 2, 1, 2. xp x x x f x x x q x x x plus equals plus 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 plus. At x equals 1, p 1 equals q 1 equals 0. Reducing to lowest terms we have 1, 2. xg(x(x) equals plus, which gives g 1 equals 2 is not equal to 0. Thus, f has a hole at 1, 2. At x equals 2, p 2 equals 3 is not equal to 0 and q 2 equals 0. Thus x equals 2 gives a vertical asymptote. Since the degree of the numerator is equal to the degree of the denominator, y equals 1 is a horizontal asymptote. D2 1, 1, 1, 2 pxxxfxqxxx plus equals plus plus p 2 is not equal to 0 and q 2 equals 0. Thus x equals 2 is a vertical asymptote. Again p 1 equals q 1 equals 0. However, after simplification by factorizing, we find that x equals 1 is a vertical asymptote. Since n equals 2. Example 4. Find the oblique asymptote of the function 1, 1, 2 plus equals x x f x. Solution. Since the degree of the numerator is 1 more than that of the denominator, the graph of f has an oblique asymptote. Applying long division yields 1, 1, 2 plus equals x x f x equals 2, 1, 1xx++. Thus, the equation of the oblique asymptote is the quotient part of the answer, which would be y equals x plus 1. Activity 2.10. For each of the following rational functions, find the domain and identify the type of asymptotes. A3, for fx. X equals plus b21, x fx. X plus equals c2. 3, 9. X fx. X equals d2, 1. X fx. X equals plus e4, 1, 3. X fx. X equals f22, 1. X fx. X equals. Unit 2 Rational expressions and rational functions. 59. The zeros of a rational function. Definition 2.8. Let Px fx qx equals be a rational function. An element in the domain of f is called a zero of f, if and only if p, a, equals 0. Example 5. Find the zeros of the following rational functions. A 2, 3, 3, 2, 2, 2. Plus equals x x x x f x b 9 6 9, 2 2. Plus equals x x x f x. Solution. We first factorize both numerator and denominator. 1, 2, 1, 3. X x f x x x plus equals plus the domain is \1, 3. Now for any x in the domain f, x equals 0 means the numerator x2 plus 3x plus 2 equals 0. i.e. x equals 1 or x equals 2. But, since x equals 1 is not in the domain of f, the only zero of f is x equals 2. b. Factorize both numerator and denominator. 3, 3, 3. 2 plus equals x x x f x. The domain is \3, 3. The numerator is 0 at x equals 3. But since 3 is not in the domain f, f has no 0. 2.3.2 Graphs of rational functions. In this subsection, you will use the zeros and asymptotes of rational functions to help draw their graphs. Steps to sketch the graph of a rational function. 1. Reduce the rational function to lowest terms and check for any open holes in the graph. 2. Find x-intercept, s by setting the numerator equal to 0. 3. Find the y-intercept, if there is one, by setting x equals 0 in the function. 4. Find all its asymptotes, if any. 5. Determine the parity, i.e. whether it is even or odd or neither. Mathematics Grade 11. 60. 6. Use the x-intercepts and vertical asymptote, s, to divide the x-axis into intervals. Choose a test point in each interval to determine if the function is positive or negative there. This will tell you whether the graph approaches the vertical asymptote in an upward or downward direction. 7. Sketch the graph. Except for breaks at the vertical asymptotes or cusps, the graph should be a nice smooth curve with no sharp corners. To draw the graph of Px/Fx/Qx equals, we need to find criteria. Domain r \x, q, x, equals 0. X, intercept 0 of f. Y, intercept x equals 0 and 0 set membership symbol domain of f. Vertical asymptote p, x, is not equal to 0 and q, x, equals 0. Horizontal asymptote degree of p, x, less than or equal to degree of q, x. Oblique asymptote degree of p, x, equals degree q, x, plus 1. Parity f is odd or even or neither. GROUPWORK2. GROUPWORK2. 2. Do the following in groups. For each of the following functions, find the domain, x-intercept, the y-intercept, the asymptotes and the parity, if they exist. List them in tables. A 2, 2, 3, 1, plus plus equals x x x f x b 1 5 6, 2 plus 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 equals x x x f x c 4 2, 2 equals x x f x. Example 6. Sketch the graph of each of the following functions. A 2, 1, x f x equals b, 2, 1, 3, 2, plus equals x x x f x. C2, 2, 3, 1, plus plus equals x x x f x d 1 5 6, 2 plus 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 equals x x x f x. E4 2, 2 equals x x f x. Unit 2. Rational expressions and rational functions. 61. Solution. The function f x equals to 1x cannot be reduced any further. This means that there will be no open holes on the graph of this function. X, intercept none, y, intercept none, vertical asymptote x equals 0, horizontal asymptote y equals 0, oblique asymptote none, parity f is even. Next, we find and plot several other points on the graph. X 2 1 1 2, y equals 2 1, x 1 4 1 1 1 4. This table is called a table of values. Finally, we draw curves through the points, approaching the asymptotes. Figure 2.2. B. The function 2, 1 3, 2 plus equals x x x f x cannot be reduced any further. This means that there will be no open holes on the graph of this function. F x equals 2 1 x x y 1 2 3 4 1 2 3 4 4 3 2 1 1 2 3 4 5. Mathematics grade 11. 62. X, intercept x equals 0 or 0 0. Y, intercept y equals 0 or 0 0. Vertical asymptote x equals 1 and x equals 2. Horizontal asymptote y equals 3. Note that the graph crosses the horizontal asymptote at x equals 2. Oblique asymptote none, parity f is neither even nor odd. You can check this by taking a test point. For instance, f 4 is not equal to f 4, and f 4 is not equal to f 4. Next, we find and plot several other points on the graph. X 3 1 4 5. Y 2.7 1.5 4.8 4.17. Finally, we draw curves through the points, approaching the asymptotes. Thus, the graph of f is Figure 2.3. You have already found the necessary data to sketch the graphs of the functions in C, D, and E in group work 2.4. We only need to give the sketches of the graphs x, y, 1 2 3 4, 1 2 3 4, 4 3 2 1 1 2 3 4 5, 5 6 7 8, 5 6 7, 2 3 2 1, x f x x x equals plus. Unit 2 Rational expressions and rational functions. 63. Note: if Pxfxqx equals is in lowest terms and nxa is a factor of q, x, then the graph of f goes in opposite directions about the vertical asymptote x equals a when n is odd. The graph of f goes in the same direction about the vertical asymptote x equals a when n is even. See Figure 2.4. D. Figure 2.5. Observe that the graph of f approaches the line y equals x plus 4 as x approaches infinity or as x approaches infinity. 2 1, 2, 3, x f x x x plus equals plus x y 1 2 3 4 5 1 2 3 4 5 4 3 2 1 1 2 3 4 5 5 2 5 6 1 x x f x x plus plus equals plus x y 1 2 3 4 1 2 3 4 5 4 3 2 1 1 2 3 6 7 Mathematics Grade 11 64 E X Y 1 2 3 4 5 1 2 3 4 5 4 3 2 1 1 2 3 4 2 2 4 x f x x equals Figure 2.6 Activity 2.11 Using the graphs drawn in example 6 above, solve each of the following inequalities. AI2 1 0 x 1 0 x BI2 3 0 2 1 x x x plus 2 2 3 0 2 1 x x x plus CI2 1 0 2 3 x x x plus 2 2 1 0 2 3 x x x plus DI 2 5 6 0 1 x x x plus 2 2 5 6 0 1 x x x plus EI2 20 4xx 4xx Exercise 2.7 Exercise 2.7 1. Sketch the graph of each of the following rational functions. A 2 8 12 2 2 equals xx xx fxb1 3 5 2 2 2 equals xxxfxc1 2 3 plus equals xxfx d5 3 4 2 plus equals xxxfxe2 2 2 3 2 1 xxfx x plus equals plus f9 2 2 plus equals xxfx g2 2 plus equals x xxfxh 2 1 3 plus equals xxxfxi3 9 2 equals xxfx 2. For the rational functions in question 1b, d, and h, solve the inequalities f x 0 and f x. Unit 2 Rational expressions and rational functions. 65. Key terms. Domain partial fractions graphs of rational functions rational equations horizontal asymptote rational expression least common multiple rational functions oblique asymptote vertical asymptote operations on rational expressions zeros of a rational function. Summary. 1. A rational expression is the quotient of two polynomials. 2. Let Px Qx and Rx be polynomials such that Q x is not equal to 0, then Px Rx Px Rx Qx 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 plus equals and Px Rx Px Rx Qx 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 equals 3. If Px Qx Rx and S x are polynomials such that Qx 0 is not equal to Sx 0 is not equal to, then Px Rx Px Rx Qx Sx Qx Sx equals and Px Rx Px Sx Qx Sx Qx Rx divided by equals for R x is not equal to 0. 4. A rational equation is an equation where one or more of the terms are fractional ones. 5. A rational function is a function of the form f x equals px qx, where p x and q x are polynomials in x and q x is not equal to 0. 6. The line x equals a is called a vertical asymptote of the graph of f if f, x, rightward arrow plus or minus infinity as x rightward arrow from the left or the right. 7. The line y equals b is called a horizontal asymptote of the graph of f, if f, x, rightward arrow b as x rightward arrow plus or minus infinity. 8. An asymptote of the form y equals mx plus b, m is not equal to 0, is called an oblique asymptote. 9. A 0 of f, x, equals p x q x is a value for which p, a, equals 0 but q, a, is not equal to 0. Mathematics Grade 11. 66. Review exercises on Unit 2. 1. Simplify each of the following rational expressions. A 2246xxx plus b2263 plus C2252xxx324382781xxxx+++++ to perform the indicated operations and simplify. A 5522xx plus b22 16299xxx plus C 2 211111 xxx x plus D22221123443xxxxxxx plus I E2222516 5 4 xxxx plus divided by plus F3121112 xx x divided by plus 3. Decompose the following rational expressions into partial fractions. A 23xx3b2143xxx plus C223 1 xx D3x1xx plus E32x1xx plus F2251 4 xxx plus 4. State the domain and solve each of the following rational equations. A 22451 xxx equals b641 xxxx plus equals plus C33133YYY plus equals plus D22113YYYY333 plus equals 5. State the domain and sketch the graph of each of the following rational functions. Find intercepts and asymptotes, if there are any. AF x equals 32xx plus BG x equals 23 5 xcf x equals 221x plus dg x equals 254x xef x equals x plus 21x fg x equals 3221x x plus unit outcomes. After completing this unit, you should be able to understand specific facts and principles about lines and circles. Know basic concepts about conic sections. Know methods and procedures for solving problems on conic sections. Main contents 3.1 Straight line 3.2 Conic sections Key terms Summary review exercises. Coordinate geometry. Unit 3. Mathematics Grade 11. 68. Introduction. The method of analytic geometry reduces a problem in geometry to an algebraic problem by establishing a correspondence between a curve and a definite equation. The concepts of lines and conics occur in nature and are used in many physical situations in nature, engineering, and science. For instance, the Earth's orbit around the Sun is elliptical, while most satellite dishes are parabolic. In this unit, you will study some more about straight lines and circles, and also the properties of the conic sections, circle, parabola, ellipse, and hyperbola. Historiae el Notii. Apollonius of Perga. The Greek mathematician Apollonius, who died about 200 BC, studied conic sections. Apollonius is credited with providing the names ellipse, parabola, and hyperbola, and for discovering that all the conic sections result from intersection of a cone and a plane. The theory was further advanced to its fullest form by Fermat, Descartes, and Pascal during the 17th century. Opiniing paraboleum. A parabolic arch has dimensions as shown in the figure. Can you find the equation of the parabola? What are the respective values of y for x equals 5, 10, and 15? Figure 3.1. X, y. 4 feet. 4 feet, 4 feet, 4 feet. 20 feet. 40 feet. Unit 3 Coordinate geometry. 69. 3.1 Straight line. Review on equation of a straight line. In grade 10, you have learned how to find the equation of a line and how to tell whether two lines are parallel or perpendicular by looking at their slopes. Now let us revise these concepts with the following activity. Activity 3.1. 1. Given 2 points P, 1, 4, and Q, 3, 2, Find the equation of a line passing through P and Q, and identify its slope and y-intercept. 2. Given the following equations of lines, characterize each line as vertical, horizontal, or neither. AY equals 3x, 5by equals 7c, x equals 2d, x plus y equals 0. 3. Identify each of the following pairs of lines as parallel, perpendicular, or intersecting, but not perpendicular. A1, y equals 2x plus 3, 2. Y equals 1 to 2x. B1, y equals 2x plus 3, 2. Y equals 1 3 2x. C1, y equals 2x plus 3, 2. Y equals 2x plus 5. D1, 3x plus 4y, 8 equals 0 2, 4x, 3y, 9 equals 0. From the above activity, you can summarize as follows. Any 2 points determine a straight line. If P, x1, y1, and Q, x2, y2, are points on a line with x1 is not equal to x2, then y1 equals 2 1 1 2 1, yxxxx is the equation of the straight line and the ratio 2 1 2 1. Ymxx equals is the slope of the line. If x2 equals x1, then the line is vertical and its equation is given by x equals x1. In this case the line has no slope. If two lines 1 and 2 have the same slope, then the two lines are parallel. Mathematics Grade 11. 70. If the product of the slopes of two lines 1 and 2 is 1, then the two lines are perpendicular. If the equation of a line is given by y equals mx plus b, then m is the slope of the line and b is its y-intercept. Example 1. Find the equation of the line that passes through the points 3, 2, and 4, 7, and identify its slope. Solution. The slope is given by m equals 7 to 5 equals 4, 3, 7. Thus, for any point P, x, y, on the line, 2 5 equals 3, 7 yxy equals 5 29 plus 7 7x. 3.1.1 Angle between two lines on the coordinate plane. In the previous section, you have seen how to identify whether two lines are parallel or perpendicular. Now, when two lines are intersecting, you will see how to define the angle between the two lines and how to determine this angle. GROUPWORK 3. 1 GROUPWORK3. 1. Consider the following graph and answer the questions that follow. Figure 3.2 Find a tan alpha b slope of the line. See the relation between alpha and slope of d. If is vertical, then alpha equals underscore 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 x y 1 2 3 4 5 1 2 3 4 5 4 3 2 1 1 2 3 p x y q xo 0 alpha y xxo. Unit 3 Coordinate Geometry. 71. If is horizontal, then alpha equals underscore 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 f. If alpha 90 degrees, do you get the same relation as in C above between tan alpha and the slope of the line? Definition 3.1 The angle alpha measured from the positive x-axis to a line in the counterclockwise direction is called the angle of inclination of the line. Example 2 If the angle of inclination of a line is 120 degrees, then its slope is tan 120 equals 3. Example 3 If the slope of a line is 1, then its angle of inclination is 45 degrees. Activity 3.2. Consider the following two intersecting lines, and answer the questions that follow. Figure 3.3 What is the angle of inclination of one? B. What is the angle of inclination of two? C. Can you find any relation between alpha, gamma, and beta? Definition 3.2. The angle between two intersecting lines 1 and 2 is defined to be the angle beta measured counterclockwise from 1 to 2. X Y 1 2 3 4 5 1 2 3 4 5 4 3 2 1 1 2 3 Alpha 1 Beta Gamma 2 Mathematics Grade 11 72. From the above activity, you have beta equals gamma alpha, slope of 1 equals tan alpha and slope of 2 equals tan gamma. Thus beta equals gamma alpha tan beta equals tan, gamma alpha equals tan 1 plus tan gamma alpha. Hence if m1 is the slope of 1 and m2 is the slope of 2, then the tangent of the angle between two lines 1 and 2 measured from 1 to 2 counterclockwise is given by tan beta equals 2 1 1 2 1 plus m if m1 m2 is not equal to 1. So, the angle beta can be found from the above equation. Note: the denominator 1 plus m1 m2 equals 0 m1 m2 equals 110 beta is undefined beta equals 90. Thus, the angle between the two lines is 90 m1 m2 equals 1 or m1 equals 2. 1m. Example 4, given points P, 2, 3, Q, 4, 1, C, 2, 4, and D, 6, 5. Find the tangent of the angle between the line that passes through P and Q and the line that passes through C and D when measured from the line that passes through P and Q to the line that passes through C and D counterclockwise. Solution: let m1 be the slope of the line through P and Q and m2 be the slope of the line through C and D. Then, m1 equals 1321 equals 4263 and m2 equals 541 equals 624. Thus, the tangent of the angle beta between the line through P and Q and the line through C and D is tan beta equals 2112. 1134 143 12 113 11 12 11 3 4 12 equals plus. Exercise 3.1 Exercise 3.1 1. Write down the equation of the line that A passes through 6, 2, and has slope m equals 4. B passes through 6, 6, and 1, 7. C passes through 2, 4, and is parallel to the line with equation y equals 7x 10. Unit 3 Coordinate Geometry. 73. D passes through 2, 4, and is perpendicular to the line with equation y equals 2x1. E passes through 1, 3, and the angle from the line with equation y equals x plus 2 to the line is 45. To find the tangent of the angle between the given lines. A1, y equals 3x plus 2, 2, y equals x. B1, 3xy2 equals 0, 2, 4xy6 equals 0. 3. Determine B so that the line with equation 5x plus by 6 equals 0 is a parallel to the line with equation y equals 4 plus 1 7x. B perpendicular to the line with equation y equals 4 plus 1 7x. 4. A car rental company leases automobiles for a charge of 20 bar/day plus 2 bar/km. Write an equation for the cost y bar in terms of the distance x driven, if the car is leased for 5 days. 5. Water in a lake was polluted with sewage from a nearby town with 7 milligrams of waste compounds per 1,000 L of water. It is determined that the pollution level would drop at the rate of 0.75 milligrams of waste compounds per 1,000 of water per year, if a plan proposed by environmentalists is followed. Let 2001 correspond to x equals 0 and successive years correspond to x equals 1, 2, 3. Find the equation y equals mx plus b that helps predict the pollution level in future years, if the plan is implemented. 3.1.2 Distance between a point and a line on the coordinate plane. Activity 3.3. Given a line and a point P not on a, draw line segments from point P to as many as possible. B. Which line segment has the shortest length? Definition 3.3. Suppose a line and a point P, X, Y, are given. If P does not lie on, then we define the distance d from P to as the perpendicular distance between P and. If P is on, the distance is taken to be 0. Mathematics grade 11. 74. Let a line, x plus by plus c equals 0 with a, b and c all non-zero be given. To find the distance from the origin to the line x plus by plus c equals 0, you can do the following. Figure 3.4. Draw on perpendicular to x plus by plus c equals 0. ONP is right-angled triangle. Thus, cos equals up cos up d alpha. The x-intercept of x plus by plus c equals 0 is CA. Thus, cos CDA equals alpha. Again, on being to the line x plus by plus c equals 0 gives slope of on equals 10 alpha equals BA. Because slope of plus equals 0 is AX by CB. This gives 2 cos equals AA plus B alpha. Hence, the distance from the origin to any line x plus by plus c equals 0 with A is not equal to 0, B is not equal to 0 and C is not equal to 0 is given by 2 plus CAB. Note: the above formula is true when IC equals 0. In this case you get a line through the origin, or to either A equals 0 or B equals 0 but not both, with C is not equal to 0, A equals 0 and B is not equal to 0 gives a horizontal line, while A is not equal to 0 and B equals 0 gives a vertical line. X, Y, 1 2 3 4 5 1 2 3 4 5 4 3 2 1 1 2 alpha x plus by plus c equals 0 and dop. Unit 3 Coordinate Geometry 75. Example 5. Find the distance from the origin to the line 5x2y7 equals 0. Solution: the distance d equals 2277 equals 5 plus 2, 29. GROUPWORK3 2 GROUPWORK3 2. 1. Consider a point P, H, K on the xy coordinate system. Form a new xy coordinate system such that the origin of the new system is at P, H, K. B. The x-axis is parallel to the x-axis and the y-axis is parallel to the y-axis. Let P be a point on the plane such that it has coordinates P, X, Y, in the xy system and P, X, Y, in the xy system. Express x and y in terms of x, y, h, and k. Figure 3.52 if h, k, equals 3, 4. What is the representation of P, 3, 2, given in the xy system, in the new xy system? From the above group work, you should get the translation formulas. X equals xh. Y equals yk, where h, k represents the origin of the new xy system and x, y, and x, y represent the coordinates of a point in the xy and xy systems, respectively. Example 6. Find the new coordinates of P, 5, 3, if the axes are translated to a new origin, 2, 3. X, y, x, h, k, kh, y, x, x, p. Mathematics Grade 11 76. Solution: the formulae are x equals xh and y equals yk. Here, h, k, equals 2, 3, thus, the new coordinates of P, 5, 3, are x equals 5, 2, equals 7 and y equals 3, 3, equals 0. Thus, in the xy system, P, 7, 0. Next, we will find the distance between any point P, H, K, and a line, x plus by plus c equals 0. Translate the coordinate system to a new origin at P, H, K. Let the equation of the line in the new xy system be a x plus by plus c equals 0. Then, the distance from P2 is given by 2 to CAB plus but ax plus by plus c equals 0 a xh plus b yk plus c equals 0 ax plus by bk plus c equals 0 ax plus by plus chbk equals 0. Since in the xy system the equation is x plus by plus c equals 0, you get a equals a, b equals b, c equals c ahbk. So c equals ah plus bk plus c equals a plus bk plus c. Hence the distance from P, H, K, to is given by 2 to a bkcab plus plus plus. Example 7. Find the distance between P, 4, 2, and 2x plus 9y3 equals 0. Solution D equals 2 4 plus 9 2 3 8 plus 18 3 7 equals 2 plus 9 85. Exercise 3.2. Exercise 3.2. 1. Find the distance of each of the following lines from the origin of 4x, 3y equals 10bx, 5y plus 2 equals 0, c 3x plus y, 7 equals 0. 2. Find the distance from each point to the given line. AP 3, 2, 5x plus 4y3 equals 0, BP 4, 0, 2x 3y2 equals 0, CP 3, 5, 2x 3y plus 11 equals 0. Unit 3 Coordinate Geometry 77. 3.2 Conic sections. 3.2.1 Cone and sections of a cone. The coordinate plane can be considered as a set of points which can be written as 2 equals times equals set membership symbol xy if some of the points of the plane satisfy a certain condition, then these points make up a subset of the set of all points, i.e. the plane. Definition 3.4 A locus is a system of points, lines, or curves on a plane which satisfy one or more given conditions. Example 1. The following are examples of loci, plural of locus. 1. The set 2, 3 5xyx set membership symbol equals plus is a line in the coordinate plane. 2. The set of all points on the x-axis which are at a distance of 3 units from the origin is 3, 0, 3, 0. In this subsection, the plane curves called circles, parabolas, ellipses, and hyperbolas will be considered. Consider two right circular cones with common vertex and whose altitudes lie on the same line as shown in Figure 3.6. Figure 3.6. Mathematics Grade 11. 78. 1. If a horizontal plane intersects/slices through one of the cones, the section formed is a circle. 2. If a slanted plane intersects/slices through one of the cones, then the section formed is either an ellipse or a parabola. 3. If a vertical plane intersects/slices through the pair of cones, then the section formed is a hyperbola. Figure 3.7. Since each of these plane curves are formed by intersecting a pair of cones with a plane, they are called conic sections. 3.2.2 Circles. Activity 3.4. Describe each of the following loci. The set of all points in a plane which are at a distance of 5 units from the origin. B. The set of all points in a plane which are at a distance of 4 units from the point P. 1, 2. Each of the loci described in Activity 3.4 represents a circle. Definition 3.5. A circle is the locus of a point that moves in a plane with a fixed distance from a fixed point. The fixed distance is called the radius of the circle and the fixed point is called the center of the circle. From the above definition, for any point P, X, Y, on a circle with center C, H, K, and radius R, PC equals R, and by the distance formula you have 2 X H Y K R plus equals. Unit 3 Coordinate Geometry. 79. From this, by squaring both sides, you get XH 2 plus YK 2 equals R2. The above equation is called the standard form of the equation of a circle, with center C, H, K, and radius R. Figure 3.8. If the center of a circle is at the origin, i.e. H equals 0, K equals 0, then the above equation becomes 2xyr plus equals. The above equation is called the standard form of equation of a circle, with center at the origin and radius r. Example 2. Write down the standard form of the equation of a circle with the given center and radius. AC 0, 0, r equals 8bc 2, 7, r equals 9. Solution. AH equals K equals 0 and R equals 8. Therefore, the equation of the circle is x0, 2 plus y0, 2 equals 82. That is, x2 plus y2 equals 64. BH equals 2, K equals 7 and R equals 9. Therefore, the equation of the circle is x2, 2 plus y plus 7, 2 equals 92. That is, x2, 2 plus y plus 7, 2 equals 81. Example 3. Write the standard form of the equation of the circle with center at C, 2, 3, and that passes through the point P, 7, 3. X, Y, P, X, Y, R, C, H, K. Mathematics Grade 11. 80. Solution. Let R be the radius of the circle. Then the equation of the circle is x2, 2 plus y3, 2 equals r2. Since the point P, 7, 3, is on the circle, you have 7, 2, 2 plus 3, 3, 2 equals r2. This implies 52 plus 6, 2 equals r2. So, r2 equals 61. Therefore, the equation of the circle is x2, 2 plus y3, 2 equals 61. Example 4. Give the center and radius of the circle. A. x5, 2 plus y plus 7, 2 equals 64. B2, 2xy, xy plus equals 680. Solution. The equation is x5, 2 plus y plus 7, 2 equals 82. Therefore, the center C of the circle is C, 5, 7, and the radius R of the circle is R equals 8. B. By completing the square method, the equation is equivalent to 2x equals 6 9 8 16 9 16 25. This is equivalent to 2 3 4 5 xy equals. Therefore, the center C of the circle is C, 3, 4, and the radius R of the circle is R equals 5. Activity 3.5. 1. Find the perpendicular distance from the center of the circle with equation x1, 2 plus y plus 4, 2 equals 16 to each of the following lines with equations. A 3x4y1 equals 0. C 3x4y plus 2 equals 0. B 3x4y plus 1 equals 0. 2. Sketch the graph of the circle and each of the lines in question 1 above, in the same coordinate system. What do you notice? Unit 3 Coordinate Geometry. 81. From Activity 3.5, you may have observed that 1. If the perpendicular distance from the center of a circle to a line is less than the radius of the circle, then the line intersects the circle at 2 points. Such a line is called a secant line to the circle. 2. If the perpendicular distance from the center of a circle to a line is equal to the radius of the circle, then the line intersects the circle at only 1 point. Such a line is called a tangent line to the circle, and the point of intersection is called the point of tangency. 3. If the perpendicular distance from the center of a circle to a line is greater than the radius of the circle, then the line does not intersect the circle. Note: 1. A line with equation x by c equals 0 intersects a circle with equation 2. X HYKR plus equals, if and only if 2. ABKCR AB plus less than or equal to plus 2. If a line with equation x plus by plus c equals 0 intersects a circle with equation 2. X HYKR plus equals, then XH 2 plus 2AC 2XKRBB equals is a quadratic equation. In X, if B equals 0, then X equals CA is a vertical line. 2 CC ha YKRHRAA plus equals, which is a quadratic in Y. Solving this equation, you can get point S of intersection of the line and the circle. Example 5. Find the intersection of the circle with equation x1, 2 plus y plus 1, 2 equals 25 with each of the following lines. Of 4x3 y7 equals 0 bx equals 4. Solution: of 4x3 y7 equals 0 y equals 4 7 3x. So, x1, 2 plus 2 4 7 plus 1 equals 25 3. X. Mathematics Grade 11. 82. x1, 2 plus 2 4 equals 25 3. X. 9. x1, 2 plus 4x 2 equals 225. 9. x2 2x plus 1 plus 16x2 32x plus 16 equals 225. 9x2 18x plus 9 plus 16x2 32x plus 16 equals 225. 25x 250 x 200 equals 0. x2 2x 8 equals 0. X plus 2, x, 4, equals 0. X equals 2 or x equals 4. This gives y equals 5 and y equals 3, respectively. Hence the line and the circle intersect at the points P, 2, 5, and Q, 4, 3. B for the line x equals 4. 4 1, 2 plus, y plus 1, 2 equals 25. 9 plus, y plus 1, 2 equals 25. Y plus 1, 2 equals 25. 9 equals 16. Y plus 1 equals plus or minus 4. Y equals 3 or y equals 5. Hence, the intersection points of the line and the circle are 4, 3, and 4, 5. Example 6, for the circle, x plus 1, 2 plus, y1, 2 equals 13, show that y equals 3 for 2x is a tangent line. Solution: the distance from C, 1, 1, to the line, 3x plus 2y plus 8 equals 0 is 2 2. 3, 1, 2, 1, 8. 3, 2d plus equals 13 equals 13 equals 13r. Hence, y equals 3 for 2x is a tangent line to the circle. X plus 1, 2 plus, y1, 2 equals 13. Example 7. Give the equation of the line tangent to the circle with equation 2 2, 1, 1. 13x y plus equals at the point P, 3, 4. Unit 3 Coordinate Geometry. 83. Solution: first find the equation of the line that passes through the center of the circle and the point of tangent C. The point of tangent C is T, xo, yo, equals T, 3, 4, and the center is P, h, k, equals P, 1, 1. Therefore, equation of is given by 0 0. 4 4 1 equals 3, 3 1 y x x x equals, plus. This implies, 4 3 equals plus 3 2 yx, which is equivalent to, 3 9 4 2 2 yx equals. Hence 3 1 2 2 yx equals is the equation of the line. But the line is perpendicular to the tangent line to the circle at T, 3, 4. Therefore, the equation of the tangent line is given by 4242 equals 3, 3 equals, plus. Therefore 2 plus 6 3yx equals is equation of the tangent line to the circle at 3, 4. Note: if a line is tangent to a circle, xh, 2 plus yk, 2 equals r2 at a point t, xo, yo, then the equation of is given by yxh xxyk equals. Therefore, the equation of the tangent line to the circle in example 7 can be found by 4312 equals 341300 yxxx plus plus. Example 8. Find the equation of the circle with center at O, 2, 5, and the line with equation xy equals 1 is a tangent line to the circle. Solution: the distance from the center O, 2, 5, of the circle to the line with equation xy1 equals 0 is the radius. Thus, r equals 22251 equals 221 plus 1. Hence, the equation of the circle is x2, 2 plus y5, 2 equals 222 equals 8. Mathematics grade 11. 84. Exercise 3.3. Exercise 3.3. 1. Write the standard form of the equation of a circle with the given center and radius. AC 2, 3, r equals 5 bc, 8, 2, r equals 2 cc, 2, 1, r equals 4. To find the coordinates of the center and the radius for each of the circles whose equations are given. A. x2, 2 plus y3, 2 equals 7b, x plus 7, 2 plus y plus 12, 2 equals 36 c4, x plus 3, 2 plus 4, y plus 2, 2 equals 7d, x1, 2 plus y plus 3, 2 equals 20 e2 2xy plus equals 8 12 12 0 f2 2xy plus equals 24803. Write the equation of the circle described below. It passes through the origin and has center at 5, 2. B. It is tangent to the y-axis and has center at 3, 4. C. The endpoints of its diameter are 2, 3, and 4, 5. 4. A circle has center at 5, 12, and is tangent to the line with equation 2xy plus 3 equals 0. Write the equation of the circle. 5. Find the equation of the tangent line to each circle at the indicated point. Ax2 plus y2 equals 145, p. 9, 8, b. x2, 2 plus y3, 2 equals 10, p. 1, 2, 3.2.3 Parabolas. Activity 3.6. 1. Draw the graph of each of the following functions. A 2yxx equals plus 2 3b 2yxx equals plus 5 4 2. Find the axis of symmetry of the graphs in question 1 above. From activity 3.6, you have seen that the graphs of both functions are parabolas. One opens upward and the other opens downward. Definition 3.6. A parabola is the locus of points on a plane that have the same distance from a given point and a given line. The point is called the focus and the line is called the directrix of the parabola. Unit 3 Coordinate Geometry. 85. Figure 3.9. Consider Figure 3.9. Here are some terminologies for parabolas. F is the focus of the parabola. The line is the directrix of the parabola. The line which passes through the focus F and is perpendicular to the directrix is called the axis of the parabola. The point V on the parabola which lies on the axis of the parabola is called the vertex of the parabola. The chord BB through the focus and perpendicular to the axis is called the latus rectum of the parabola. The distance P equals VF from the vertex to the focus is called the focal length of the parabola. Historia Nudi. Galileo Galilei, 1564 to 1642. In the 16th century, Galileo showed that the path of a projectile that is shot into the air at an angle to the ground is a parabola. More recently, parabolic shapes have been used in designing automobile highlights, reflecting telescopes, and suspension bridges. Now you are going to see how to find equation of a parabola with its axis of symmetry parallel to one of the coordinate axes. There are two cases to consider. The first case is when the axis of the parabola is parallel to the x-axis, and the second case is when the axis of the parabola is parallel to the y-axis. X, y, b, f, b, v, p. Axis. Mathematics Grade 11. 86. Equation of a parabola whose axis is parallel to the x-axis. AB Figure 3.10. Let V, HK be the vertex of the parabola. The axis of the parabola is the line y equals k. If the focus of the parabola is to the right of the vertex of the parabola, then the focus is f, h plus pk, and the equation of the directrix is xhp equals. Let p, x, y be a point on the parabola. Then the distance from P to F is equal to the distance from P to the directrix. That is, PFPA equals where A, HPY. This implies 2222 plus equals plus xhpyk xhpyy squaring both sides gives you 222. xhpyk xhp plus equals this implies 22222x xhp hpyk x xhp hp plus equals plus 2. This can be simplified to the form 2, 4, ykpxh equals. This equation is called the standard form of equation of a parabola with vertex v, hk, focal length p. The focus f is to the right of the vertex and its axis is parallel to the x-axis. The parabola opens to the right. If the focus of the parabola is to the left of the vertex of the parabola, then the focus is f, hpk, and the equation of the directrix is xhp equals plus. With the same procedure as above, you can get the equation 2, 4, ykpxh equals x, y, x equals hp, f, h plus p, k, a, hp, y, p, x, y, v, h, k, x, y x equals h plus p, f, hp, k, p, x, y, a, h plus y, v, h, k. Unit 3 Coordinate Geometry 87. This equation is called the standard form of the equation of a parabola with vertex v, hk, focal length, p. The focus f is to the left of the vertex and its axis is parallel to the x-axis. In this case, the graph of the parabola opens to the left. The standard form of the equation of a parabola with vertex v, h, k, and whose axis is parallel to x-axis is given below. Such a parabola is called an x-parabola. Note: the equation 2, 4, ykpxh equals plus or minus represents a parabola with vertex v, h, k, focus, hpk plus or minus directrix, xhp, equals plus or minus axis of symmetry y equals k. If the sign in front of p is positive, then the parabola opens to the right. If the sign in front of P is negative, then the parabola opens to the left. Example 9. Find the equation of the directrix, the focus of the parabola, the length of the latus rectum, and draw the graph of the parabola. y2 equals 4x. Solution: the vertex is at 0, 0, and 4p equals 4. Hence p equals 1. The parabola opens to the right with focus h plus p, k, equals 0 plus 1, 0, equals 1, 0, and the directrix x equals h, p equals 0 to 1 equals 1. The axis of the parabola is the x-axis. The latus rectum passes through the focus f, 1, 0, and is perpendicular to the axis, that is the x-axis. Therefore, the equation of the line containing the latus rectum is x equals 1. To find the endpoints of the latus rectum, you have to find the intersection point of the line x equals 1 and the parabola, that is, 2y equals times equals plus or minus 4142. Therefore, the endpoints of the latus rectum are 1, 2, and 1, 2, and the length of the latus rectum is 2, 2, 1, 1, 2, 2, 16, 4, plus equals. The graph of the parabola is given in figure 3.11. Mathematics grade 11. 88. Figure 3.11. Example 10. Find the equation of the directrix and the focus of each parabola and draw the graph of each of the following parabolas. Of 4y2 equals 12xb, y2, 2 equals 6, x, 1, c2 yx plus equals 6 8 25 0. Solution: the equation for y2 equals 12x can be written as y2 equals 12 3 4. X equals, the vertex is v, h, k, equals v, 0, 0. 4p equals 3 and 3 4p equals. Since the sign in front of p is negative, the parabola opens to the left. The directrix is 3 3 plus 0 equals 4 4x hp equals plus. The focus is 3 3 f 0 0 f 0 4 4 hpk equals. The graph of the parabola is given in figure 3.12. Figure 3.12. y2 equals 4x. 1 2 3 4 5. 1 2 3 4 5 2 3 4 5 2 1 1 X Y 3 F 1 0 V 0 0 6 X equals 1 1 2 3 4 1 2 3 4 5 2 3 4 2 1 1 X Y 5 4 3 Y2 equals 3X 3F0 4V 0 0 X equals 3 4 Unit 3 Coordinate Geometry 89 B. The vertex is at V H K equals V 1 2 Since 4P equals 6, then P equals 6 3 4 2 equals. The sign in front of P is positive. Hence the parabola opens to the right. The focus is F H plus P K equals 3 5 F1 2 F 2 2 2 plus equals. The directrix is X equals H P equals 3 1 1 2 2 equals. The axis of the parabola is the horizontal line y equals k, i.e. y equals 2, and the graph of the parabola is given in figure 3.13. Figure 3.13. See by completing the square, the equation y26y plus 8x plus 25 equals 0 is equivalent to the equation y 3 2 equals 8 x plus 2. The vertex of the parabola is at V H K equals V 2 3 and 4P equals 8 implies P equals 2. The sign in front of P is negative. Hence the parabola opens to the left. The focus F H P K equals F 2 2, 3 equals F 4 3. The equation of the directrix is xhp plus 2 2 0, and the equation of the axis of the parabola is y equals k, i.e. y equals 3 with its graph given in figure 3.14. Figure 3.14. y2 2 equals 6, x1 1 2 3 4 5 1 2 3 4 5 2 3 2 1 1 x y 3 5 f2 2 6 6 7 y equals 2 x equals 1 2 v 1 2 1 2 1 2 1 1 x 6 5 4 3 y3 2 equals dash 8 x plus 2 v 2 3 x equals 0 f 4 3 y equals 3 2 2 3 4 5 y 6 7 8 8 7 Mathematics grade 11 90 Example 11 Find the equation of the parabola with vertex v 1 4 and focus f 5 4 Solution here v h k equals v 1 4 hence h equals 1 and k equals 4 and the focus is given by f h plus p k equals f 5 4 This implies h plus p equals 5 and k equals 4. Then, 1 plus p equals 5, which implies p equals 6 since the focus f is to the right of the vertex v, the parabola opens to the right. Hence the equation of the parabola is given by y4, 2 equals 24, x plus 1, equation of a parabola whose axis is parallel to the y-axis. AB. Figure 3.15 Let v, hk be the vertex of the parabola. The axis of the parabola is the line xh equals. If the focus of the parabola is above the vertex of the parabola, then the focus is f, hkp plus and the equation of the directrix is ykp equals. Let p, x, y be a point on the parabola. Then the distance from P to F is equal to the distance from P to the directrix. That is, PFPA equals where A, XKP as shown in figure 3.15. This implies 2222 plus equals plus XHYKP XXYKP. This can be simplified to the form 2, 4, XHPYK equals the standard form of equation of a parabola with vertex v, h, k, and whose axis is parallel to the y-axis. Such a parabola is called a y-parabola. X, y, y equals kp, p, x, y, a, x, kp, v, h, k, f, h, k plus p. X equals h, x, y, y equals k plus p, p, x, y, a, x, k plus p, V H K F H K P X equals H. Unit 3 Coordinate Geometry 91. Note: the equation 2, 4, x h p y k equals plus or minus represents a parabola with vertex v, h, k, focus f. HKP plus or minus directrix, YKP equals axis of symmetry x equals h. If the sign in front of P is positive, then the parabola opens upward. If the sign in front of P is negative, then the parabola opens downward. Example 12. Find the vertex, focus and directrix of the following parabolas. Sketch the graphs of the parabolas in B and C. Ax2 equals 16y, b2 x2 equals 8y. C x 2 equals 8. Y plus 1, d2x x plus equals 12 to 11 0. Solution: here 4p equals 16 implies p equals 4. Since the sign in front of p is positive, the parabola opens upward. The vertex is v, h, k, equals v, 0, 0. The focus is f, 0, p, equals f, 0, 4. The directrix is y equals k, p equals 0 to 4 equals 4. b2 x2 equals 8y can be written as x2 equals 4y. Here, 4p equals 4 implies p equals 1. Since the sign in front of p is negative, the parabola opens downward as shown in figure 3.16. The vertex is v, h, k, equals v, 0, 0. The focus is f, h, k, p, equals f, 0, 0, 1, equals f, 0, 1. The directrix is y equals k plus p equals 0 plus 1 equals 1. Figure 3.16 Figure 3.17 x2 equals 4y 1 1 2 3 4 5 2 3 4 x y 3v 0 0 y equals 1 f 0 1 4 2 3 4 5 6 1 2 1 x2 2 equals 8 y plus 1 1 1 2 3 4 5 2 3 4 x y 3 v 2 1 y equals 3 f 2 1 2 3 4 5 6 1 2 1. Mathematics grade 11. 92. See here 4p equals 8 implies p equals 2. Since the sign in front of p is positive, the parabola opens upward as shown in figure 3.17. The vertex v, h, k, equals v, 2, 1. The focus is f, h, k plus p, equals f, 2, 1 plus 2, equals f, 2, 1. The directrix is y equals k, p equals 1 to 2 equals 3. D. The equation 2xyx plus equals 12 to 11 0 is equivalent to 2, 1, 12, 1, xy equals. Hence 4p equals 12 implies p equals 3, since the sign in front of p is negative, the parabola opens downward. The vertex is v, h, k, equals v, 1, 1. The focus is f, h, k, p, equals f, 1, 1 3, equals f, 1, 2. The directrix is y equals k plus p equals 1 plus 3 equals 4. Example 13. Parabolic reflector. A paraboloid is formed by revolving a parabola about its axis. A spotlight in the form of a paraboloid 6 inches deep has its focus 3 inches from the vertex. Find the radius r of the opening of the spotlight. Solution. First locate a parabolic cross-section containing the axis in a coordinate system and label all the known parts and parts to be found as shown in figure 3.18. The parabola has the y-axis as its axis and the origin as its vertex. Hence the equation of the parabola is x2 equals 4 pi. The focus is given f, 0, 3, equals f, 0, p, thus p equals 3 and the equation of the parabola is x2 equals 12y. The point, r, 6, is on the parabola. 2r equals times 12 6. r2 equals 72. r equals 72 8.49 inches. Figure 3.18. -10 -8 -6 -4 -2 2 4 6 8 10. Y. Spotlight. R 6 6 8 10. Unit 3 Coordinate Geometry. 93. Exercise 3.4 Exercise 3.4. 1. Write the equation of each parabola given below. A vertex, 2, 5, focus, 2, 8, B vertex, 3, 4, focus, 3, 12, C vertex, 4, 6, focus, 8, 6, D vertex, 1, 8, focus, 6, 8, to name the vertex, focus and directrix of the parabola whose equation is given and sketch the graph of each of the following. Ax2 equals 2yb, x plus 2, 2 equals 4, y6, c, y plus 2, 2 equals 16, x3, d, x3, 2 equals 4 y3. Write the equation of each parabola described below. Of focus, 3, 5, directrix y equals 3b vertex, 2, 1, axis y equals 1, p equals 1 c vertex, 4, 3, passes through, 5, 2, vertical axis d focus, 5, 0, p equals 4, vertical axis 4. Write the equation of each parabola described below. A vertex at the origin, axis along the x-axis, passing through a 3, 6, b vertex at 4, 2, axis parallel to the x-axis, passing through a 8, 7, c vertex at 5, 3, axis parallel to the y-axis, passing through b, 1, 2, 5. The parabola has a multitude of scientific applications. A reflecting telescope is designed by using the property of a parabola. If the axis of a parabolic mirror is pointed toward a star, the rays from the star, upon striking the mirror, will be reflected to the focus. Answer the following questions. A parabolic reflector is designed so that its diameter is 12 m when its depth is 4 m. Locate the focus. B. A parabolic headlight lamp is designed in such a way that when it is 16 cm wide it has 6 cm depth. How wide is it at the focus? 6. Find the equation of the parabola determined by the given data. The vertex is at 1, 2. The axis is parallel to the x-axis and the parabola passes through 6, 3. B. The focus is at 3, 4. The directrix is at x equals 8. Figure 3.19. P. Fx. Y. Axis alpha alpha. Mathematics grade 11. 94. 3.2.4 ellipses. GROUPWORK3. GROUPWORK3. 3. Do the following in groups. 1. Draw a circle of radius 5 centimeters. 2. Using 2 drawing pins, a length of a string and a pencil, do the following. Push the pins into a paper at 2 points. Tie the string into a loose loop around the 2 pins. Pull the loop taut with the pencil's tip so as to form a triangle. Move the pencil around while keeping the string taut. 3. What do you observe from the 2 drawings? Definition 3.7. An ellipse is the locus of all points in the plane such that the sum of the distances from 2 given fixed points in the plane, called the foci, is constant. Figure 3.20. Consider Figure 3.20. Here are some terminologies for ellipses. F and F are foci. V, B, and B are called vertices of the ellipse. VV is called the major axis and BB is called the minor axis. C, which is the intersection point of the major and minor axes, is called the center of the ellipse. X, Y, B, BV, V, A, F, FC. Unit 3 Coordinate Geometry. 95. CV and CV are called semi-major axes and CB and CB are called semi-minor axes. Chord A, which is perpendicular to the major axis at F, is called the latus rectum of the ellipse. The distance from the center to a focus is denoted by C. The length of the semi-major axis is denoted by A and the length of the semi-minor axis is denoted by B. The eccentricity of an ellipse, usually denoted by E, is the ratio of the distance between the 2 foci to the length of the major axis, that is, distance between the 2 foci length of the major axis CEA equals, which is a number between 0 and 1. Note that VF equals VF and VF plus VF equals VV equals 2A, according to the definition. If P is any point on the ellipse, you have PF plus PF equals 2A. Since B is on the ellipse, you also have that BF plus BF equals 2A. But BF equals BF. This implies BF equals A. By using Pythagoras' theorem for right-angled triangle BCF, you get CB2 plus CF2 equals BF2. But CB equals B, CF equals C and BF equals A. Therefore A, B and C have the relation 222BCA plus equals. Historique el note. Johannes Kepler, 1571 to 1630, in the 17th century, Johannes Kepler discovered that the orbits along which the planets travel around the Sun are ellipses with the Sun at one focus, his first law of planetary motion. Equation of an ellipse whose center is at the origin. There are two cases to consider. One of these cases is where the major axis of the ellipse is parallel to the x-axis as shown in figure 3.21 below. Mathematics grade 11. 96. Figure 3.21. From the discussion so far, you have PF plus PF equals 2A. This implies 2 2 2 2 plus equals 2xcy xcya. 2 2 2 2 plus equals 2 plus xcya xcy. Squaring both sides gives you x plus c, 2 plus y2 equals 4 a 2 4 a 2 2 2 2, plus xcy xcy. Thus, 4 a 2 2 2 2 2, plus equals 4 plus xcya xc. This implies 4 a 2 2 2 2 2 2 2, c, plus equals 4 plus 2 xya xxcc xxcc. This gives you the result 2 2 2a xcya cx, plus equals. Squaring both sides gives a 2 2 2 2 2, plus equals xcya cx. A 2 x2 2xc plus c2 plus y2 equals a 4 2 a 2cx plus c2x2. A 2x2 2 a 2cx plus a 2c2 plus a 2y2 equals a 4 2 a 2cx plus c2x2. A 2c2 x2 plus a 2y2 equals a 4 a 2c2. A 2c2 x2 plus a 2y2 equals a 2, a 2c2. From the relation a 2 equals b2 plus c2, you get a 2c2 equals b2. This gives you b2 x2 plus a 2y2 equals a 2b2 x y v a 0 c 0 0 v a 0 f c 0 f c 0 b 0 b 0 b. Unit 3 Coordinate Geometry. 97. By dividing both sides by a 2b2, you have 22221xyab plus equals. This equation is called the standard form of an equation of an ellipse whose major axis is horizontal and center is at 0, 0. Example 14. Give the coordinates of the foci of the ellipse shown below. Give the equation of the ellipse and find the eccentricity of the ellipse. Figure 3.22 Solution from the graph. Observe that A equals 10, and B equals 6. Since A2 equals B2 plus C2, then 2 100 equals 36 plus C, hence C2 equals 64. This implies C equals 8. Therefore, the center is C, 0, 0, and the foci are F, C, 0, equals F, 8, 0, and F, C, 0, equals F, 8, 0, since the major axis is horizontal. Then the equation of the ellipse is 2 plus equals 136 xy. The eccentricity of the ellipse is 80.810 CEA equals. Example 15. Find the equation of the ellipse with foci f, 2, 0, and f, 2, 0, A equals 7. Solution f, 2, 0, and f, 2, 0, implies that c, 0, 0, and c equals 2. The major axis of ellipse is horizontal. From the relation A2 equals B2 plus C2, you get B2 equals A2, C2 equals 72, 22 equals 45. Hence, the equation of the ellipse is 2 plus equals 1xyab, or 2 plus equals 149.45 xy. 0, 6, 10, 642, 2, 4, 6. X8 642246810 0 6 10 0 10 0. Y. Mathematics Grade 11. 98. Equation of an ellipse whose center is C, H, K, different from the origin. Figure 3.23. Let C, H, K, be the center of the ellipse. Construct a new xy coordinate system with origin at C, H, K. Then, for any point P on the ellipse with coordinates x, y, in the xy coordinate system and x, y, in the new xy coordinate system, 2 plus equals 1 xyab. But then from translation formula you have x equals xh and y equals yk, which gives 2 plus equals 1 xhyk. AB, which is the standard equation of an ellipse with center at C, h, k, and major axis parallel to the x-axis. Similarly, when the major axis is vertical, the standard equation of the ellipse is given by 2 2 2 2 plus equals 1, when c, 0, 0, yxab and 2 2 2 2, plus equals 1, ykxh. AB when c, h, k. Example 16. Find the coordinates of the center, foci, the length of the major and minor axes. Draw the graph of the ellipse. Find the eccentricity of the ellipse and the length of the latus rectum. 2 2, 2, 1, plus equals 191 xy. Solution. The center of the ellipse is c, 2, 1, and the major axis is horizontal. Also 2 and 9 equals and 2b equals 1, which implies a 3 equals and b equals 1. Then the length of the major axis is 6 and the length of the minor axis is 2. Hence the vertices are v, 1, 1, v, 5, 1, b, 2, 0, and b, 2, 2. X, y, v, h, a, k, c, h, k, v, h plus a, k, f, f, h plus c, k, h, c, k, b, h, k plus b, b, h, k, b, p, x, y. Unit 3 Coordinate Geometry 99. From the relation 2 2 2 CAB equals, you get C equals 2 2 and the foci are F, 2 2 2, 1, and F, 2 2 2, 1, plus. The eccentricity E of the ellipse is 2 2 3 CEA equals. The lines containing the latus rectums are vertical lines. These lines are x equals plus 2 2 and x equals 2 2. The intersection points of the line x equals plus 2 2 and the ellipse are given by 2 2, 2, 1, plus equals 1912 plus 2y. Solving this gives you 373y plus or minus equals. Hence, the endpoints of one of the latus rectums are 3722, 3, plus or minus plus. Therefore, the length of the latus rectum is 273. The graph of the ellipse is given in Figure 3.24. Figure 3.24 Example 17 Find the coordinates of the center, foci, the length of the major and minor axes. Draw the graph of the ellipse. 2 2, plus 2, plus 2, plus equals 125 16yx. Solution: the center of the ellipse is C, 2, 2, and the major axis is vertical. Also 2a 25 equals and 2b equals 16, which implies a 5 equals and b equals 4. So the length of the major axis is 10 and the length of the minor axis is 8, and also 2 CAB equals 3. X Y C 2 1 4 1 1 1 2 3 4 5 2 3 2 1 6 7 2 B. Mathematics grade 11 100. Therefore the foci are H, K plus or minus C equals 2, 2 plus or minus 3, that is, F, 2, 5, F, 2, 1, and also the vertices are V, 2, 7, V, 2, 3, B, 6, 2, and B, 2, 2. The graph of the ellipse is given in Figure 3.25. Figure 3.25. Exercise 3.5. Exercise 3.5. 1. Write the equation of each ellipse described below. AC 0, 0, A equals 6, B equals 4, horizontal major axis B foci 3, 0, 3, 0, A equals 8 CC 0, 0, A equals 8, B equals 6, vertical major axis DC 5, 0, A equals 5, B equals 2, horizontal major axis 2. Name the center, the foci, and the vertices of each ellipse whose equation is given. Also sketch the graph of each ellipse. A 2, 2, 3, 4, plus equals 125 16 xyb 2, 2, plus 2, 1, plus equals 125 4yx. C 2, 2, 2, 3, plus equals 125 5yx. 3. Find the equation of the ellipse with the center at 1, 4, and vertices at 10, 4, and 1, 2, B foci at 1, 0, 1, 0, and the length of the major axis 6 units. C vertex at 6, 0, focus at 1, 0, and center at 0, 0. X Y 9876543211123 12345 12345 678 V 2 3 v 2 7 b 6 2 b 2 2 f 2 5 f 2 1 c 2 2. Unit 3 Coordinate Geometry 101. D center at 1 0, 2 focus at 0 1 and passing through 2 2. E center 0 0, vertex 0 5 and length of minor axis 8 units. For the planet Mars travels around the Sun in an ellipse whose equation is approximately given by 2222 plus equals 1, 228, 227, xy, where x and y are measured in millions of kilometers. Find the distance from the Sun to the other focus of the ellipse, in millions of kilometers. B. How close Mars gets to the Sun. C. The greatest possible distance between Mars and the Sun. 3.2.5 Hyperbolas. Definition 3.8. A hyperbola is defined as the locus of points in the plane such that the difference between the distances from two fixed points is a constant. The fixed points are called foci. The point midway between the foci is called the center of the hyperbola. Figure 3.26. Consider Figure 3.26. Here are some terminologies for hyperbolas. F and F are the foci of the hyperbola. C is the center of the hyperbola. VP X Y V B B A F C F. Mathematics Grade 11 102. The points V and V on each branch of the hyperbola nearest to the center are called vertices. VV is called the transverse axis of the hyperbola and CV equals CV is denoted by A and CF equals CF is denoted by C. Denote C2 A2 by B2, so that 22BCA equals the segment of symmetry perpendicular to the transverse axis at the center, which has length 2b, is called the conjugate axis. The endpoints B and B of the conjugate axis of the hyperbola are called covertices. The eccentricity of the hyperbola, usually denoted by E, is the ratio of the distance between the two foci to the length of the transverse axis, that is, distance between the two foci length of the transverse axis CEA equals, which is a number greater than 1. The chords with endpoints on the hyperbola passing through the foci and perpendicular to FF are called the latus rectums. Note: hyperbolas occur frequently as graphs of equations in chemistry, physics, biology, and economics. Boyle's law, Ohm's law, supply and demand curves. Equation of a hyperbola with center at the origin and whose transverse axis is horizontal. Consider a hyperbola with foci f, c, 0, f, c, 0, and center c, 0, 0. Then, a point P, x, y, is on the hyperbola, if and only if 2, 2, 2, 2, plus equals 2xcy plus or minus. Adding 2 plus xcy to both sides of the above equation gives you 2 plus equals 2 plus xcy plus or minus. By squaring both sides you have 2 plus equals 4 plus xcy plus or minus plus x plus c 2 plus y2. This implies plus or minus for a 2 plus equals 4 plus 2 plus 2 xcy xxcc plus. Unit 3 Coordinate Geometry 103. That is 2224 plus equals 4 plus or minus axcy axc. This implies 222 plus or minus axcy axc plus equals plus. Again, squaring both sides of the above equation gives you a 2224222 plus equals plus 2 plus xcy xc. This implies a 2c2 x2 plus a 2y2 equals a 2c2. Recall that c2 a 2 equals b2. Thus, b2x2 plus a 2y2 equals a 2b2, which reduces to 22221xyab equals. This equation is called the standard form of equation of a hyperbola with center at c, 0, 0, and transverse axis horizontal. Example 18. Find the equation of a hyperbola, if the foci are f, 2, 5, and f, 4, 5, and the transverse axis is 4 units long. Draw the graph of the hyperbola. Solution: the midpoint of FF is the center of the hyperbola and it is c, 1, 5. The transverse axis is 2a equals 4. So, A equals 2 and FF equals 2C equals 6. Besides, since F and F lie on a horizontal line, the transverse axis is horizontal. Using the relation B2 equals C2 A 2 equals 9 4 equals 5, the equation becomes 2 plus 1, 5, equals 145 xy. The graph of the hyperbola is given in figure 3.27. Figure 3.27. X, Y, F 8765432112345 1 1 2 3 4 5 6 7 8 C 1 5 VVF. Mathematics grade 11 104. Activity 3.7. Consider the hyperbola with equation 221916xy equals, and answer each of the following. A. Draw the graph of the hyperbola with the equation given above. B. Mark the points with coordinates 3, 0, plus or minus on the x-axis and with coordinates 0, 4, plus or minus on the y-axis. C. Draw a rectangle with sides passing through the points in B above and parallel to the coordinate axis. D. Draw the lines that contain the diagonals of the rectangle in C above. Asymptotes. If a point P on a curve moves farther and farther away from the origin, and the distance between P and some fixed line tends to 0, then such a line is called an asymptote to the curve. From activity 3.7 you may have observed that the lines through the diagonals of a rectangle that passes through points with coordinates 3, 0, plus or minus on the x-axis and 0, 4, plus or minus on the y-axis and parallel to the coordinate axis are asymptotes to the graph of the hyperbola with equation 221. 916xy equals. Consider the hyperbola with equation 22221. xyab equals. This equation is equivalent to 1xy xyab plus equals, or xy of ab bxi equals plus. Unit 3 Coordinate Geometry 105. One branch of the hyperbola lies in the first quadrant. If a point P on the hyperbola moves farther and farther away from the origin on this branch of the hyperbola, then x and y become infinite and a bxi plus tends to 0. This implies the line 0 or xybyxaba is an asymptote to the graph of the hyperbola. By symmetry, the line 0 or xy_by_xa plus equals is also an asymptote to the graph of the hyperbola. If you interchange x and y in the equation 2, xyab equals. The new equation becomes 2, yxab and represents a hyperbola with foci f, 0, c, and f, 0, c, vertices v, 0, a, and v, 0, a, covertices b, 0, and b, 0, center c, 0, 0, the transverse axis is on y-axis. In this case, the lines AYXB equals plus or minus are asymptotes to the graph of the hyperbola. Let C, H, K, be the center of the hyperbola. Construct a new xy coordinate system with origin at H, K. Then, for any point P on the hyperbola with coordinates x, y, in the xy coordinate system and x, y, in the new xy coordinate system, 2, xyab equals. Using translation formulae x equals xh and y equals yk, this reduces to 2, equals 1 xhykyab, which is the standard equation of a hyperbola with center at C, H, K, and transverse axis parallel to the x-axis. Mathematics Grade 11 106. Similarly, when the transverse axis is vertical, the standard equation of the hyperbola is given by 2, equals 1, when C, 0, 0, yxab and 2, equals 1, ykxhab when C, H, K. The following table gives all possible standard forms of equations of hyperbolas. Equation center transverse axis asymptotes 2, 1 xyab equals 0, 0, horizontal equals byxa plus or minus 2, equals 1 xhyk. AB, H, K, horizontal, bykxha. Equals plus or minus 2, equals 1 yxab, 0, 0, vertical equals ayxb plus or minus 2, equals 1 ykxh. AB, H, K, vertical, aykxhb equals plus or minus. Example 19. Find asymptotes of the hyperbola, if the foci are f, 2, 5, and f, 4, 5, and the transverse axis is 4 units long. Solution from example 18. The equation of the hyperbola is 2 plus 1, 5, equals 145xy. The asymptotes of the hyperbola are yk equals plus or minus bxha. That is 5, 5, 1, 2. Yx equals plus or minus plus 5, 1, 5, 2. Yx equals plus or minus plus, which gives the lines with equations 5, 5, 10, 2, 2. Yx plus equals plus, and 5, 10, 5, 2, 2. Yx equals plus. Example 20. Find the equation of the hyperbola with vertices 1, 2, and 1, 2, and b equals 2. Solution. The vertices lie on a vertical line. Thus, the equation must have the form 2, 2, 2, 2 equals 1 ykxhab. Unit 3. Coordinate geometry. 107. The center is midway between 1, 2, and 1, 2. So, C 1, 0. Also 2a equals v equals 4a equals 2. It follows that the equation is 2, 2, 0, 1 equals 144 yx, or 2, 2, 1 equals 144 yx. Example 21. Sketch the hyperbola with equation 2, 2, 16, 9, 144 yx equals. Draw its asymptotes and give the coordinates of its vertices and foci. Solution. The equation 2, 2, 16, 9, 144 yx equals is equivalent to 2, 2, 16, 9, 144 yx equals. Therefore, the equation of the hyperbola is 2, 2 equals 1916 yx. This implies the center is C, 0, 0, A equals 3, B equals 4, and the vertices of the hyperbola are V, 0, 3, and V, 0, 3. From the relation C2 equals A2 plus B2 equals 25, you get C equals 5. Hence the foci are F, H, KC, and F, H, K plus C, which implies F, 0, 5, and F, 0, 5. Asymptotes of the hyperbola are y equals axb plus or minus. That is, y equals 3, 4 plus or minus x. The graph of the hyperbola is given in Figure 3.28. Figure 3.28. x, y, f, v, c, v, f. 65432112345 1 1 2 3 4 5 2 3 4 5 6 7 8 Mathematics Grade 11 108 Exercise 3.6 Exercise 3.61 Find the equation of each hyperbola with the information given below. A center at C, 0, 0, A equals 8, B equals 5, having horizontal transverse axis. B foci at F, 10, 0, and F, 10, 0, 2A equals 16. C center C, 1, 4, A equals 2, B equals 3, vertical transverse axis. D vertices V, 2, 1, V, 2, 1, B equals 2. 2. Name the center foci, vertices, and the equations of the asymptotes of each hyperbola given below. Also sketch their graph. A 2 2 1 36 81 xy equals B 2 2 3 6 1 9 36 xy plus equals C 2 2 1 25 16 yx equals D 2 2 3 2 125 25 yx equals 3. Write the equation of each hyperbola satisfying the following conditions: a center C, 4, 2, focus F, 7, 2, vertex V, 6, 2, B center C, 4, 2, vertex V, 4, 5. Equation of one asymptote is 4y3x equals 4. C vertices at V, 0, 4, V, 0, 4, foci at F, 0, 5, F, 0, 5, D vertices at V, 2, 3, V, 6, 3, 1 focus at F, 4, 3, E. The transverse axis coincides with the x-axis, center at C, 2, 0, lengths of transverse and conjugate axes equal to 8 and 6, respectively. F. The length of the transverse axis is equal to 8. The end points of the conjugate axis are A, 5, 5, and B, 5, 3. For a hyperbola for which A equals B is called equilateral. Show that a hyperbola is equilateral, if and only if its asymptotes are perpendicular to each other. Unit 3 Coordinate Geometry. 109. Key terms. Angle of inclination, major axis, slope, intercept, form. Asymptote, minor axis, tangent line, axis, parallel lines. Translation formulas. Center, perpendicular lines, transverse axis, conjugate axis, point of tangent, C2 point, form, directrix, point, slope, form, vertex, focal length, radius, x, intercept, focus, secant line, y, intercept, lattice, rectum, slope. Summary. 1. The slope of a line through x1, y1, and x2, y2, is given by 2, 1, 2, 1. X, x2, 2-point form, if x1, y1, and x2, y2, with x1 is not equal to x2 are given, the line through them has an equation y1 equals 2, 1, 1, 2, 1, x, 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 x. 3-point slope form, if a point x1, y1, and slope m are given, the equation of the line is y1 equals m, x, x1. For slope intercept form, if the slope m and y-intercept b are given, then the equation of the line is y equals mx plus b. 5. Two lines are parallel if and only if they have the same angle of inclination. 6. The slope of a non-vertical line is tan alpha, where alpha is the angle of inclination of the line, with 0 less than or equal to alpha. Tan beta equals 1 plus mn, where m and n are the slopes of the lines. 8. Two lines are perpendicular if and only if the angle between them is 90°. 9. If two perpendicular lines are non-vertical, then mn equals 1, where m and n are their slopes. 10. The general form of equation of a line is ax plus by plus c equals 0, where a is not equal to 0 or b is not equal to 0 are fixed real numbers. Mathematics Grade 11. 110. 11. The distance from the origin to the line ax plus by plus c equals 0 is given by 2 plus bca. 12. The distance from p, h, k, to ax plus by plus c equals 0 is 2 a plus bk plus ca plus b. 13. If the xy coordinate system is translated to a new xy coordinate system with origin at c, h, k, then the translation formulae are x equals xh, y equals yk. 14. The standard form of the equation of a circle is xh 2 plus yk 2 equals r2, where h, k, is the center and r is the radius. 15. The line that touches a circle at only one point is called a tangent line and its Equation is 0000 equals YYXHXXYK, where XO, YO, is the point of tang in C and H, K, is the center of the circle. 16. The standard equation of a parabola is either XH 2 equals plus or minus 4p YK axis / to the y-axis, or YK 2 equals plus or minus 4p XH axis / to the x-axis. 17. The standard equation of an ellipse is either 2 plus equals 1 XHYKAB, major axis horizontal, or 2 plus equals 1 YKXHAB, major axis vertical, where B2 plus C2 equals a 2. 18. The standard equation of a hyperbola is either 2 equals 1 XHYKAB, transverse axis horizontal, or 2 equals 1 YKXHAB, transverse axis vertical, where a 2 plus B2 equals C2. 19. The equations of the asymptotes of a hyperbola with a horizontal transverse axis are YK equals plus or minus BXHA, and those with vertical transverse axis are YK equals plus or minus AXHB. Unit 3 Coordinate Geometry 111. Review exercises on Unit 3. 1. Write each of the following in the general form of equation of a line. AY equals 3bx equals 9cy equals 1 plus 4 2x. dy 3 equals 4xe 3x equals 7 4y2. Give the equation of the line that satisfies the given conditions. A passes through P, 2, 3, and has slope 1. B passes through P, 3, 7, and Q, 6, 10. C parallel to the line with equation y equals 3x4 and passes through A, 3, 2. D perpendicular to the line with equation 6x equals 2y4 and y-intercept 4. 3. Find the tangent of the acute angle between the following lines. A 2x plus y2 equals 0, bx 6y plus 5 equals 0, 3x plus y plus 1 equals 0, 2yx1 equals 0, cx 5y2 equals 0, dx 6y plus 5 equals 0, y4x plus 7 equals 0, 2yx1 equals 0. 4. Find the distance from the given point to the line whose equation is given. AP 4, 3, 2x 3y plus 2 equals 0, BA 0, 0, 2x 3y plus 2 equals 0, CQ 1, 0, 2x3y plus 2 equals 0 dB. 2, 4, 4y equals 3x15. Find the distance between the pairs of parallel lines whose equations are given below. A 2x3y plus 2 equals 0 and 2x3y plus 6 equals 0. b4y equals 3x1 and 8y equals 6x7. 6. Write the equation of each circle with the given conditions. A center at O, 3, 7, and radius 3. B center at P, 3, 7, and tangent to 2x plus 3y 4 equals 0. C endpoints of its diameter are A, 3, 7, and B, 4, 3, 7. Find the equation of the tangent line to the circle with equation x3, 2 plus y4, 2 equals 20 at P, 1, 0. 8. Find the equation of the parabola with the following conditions. A focus at F, 2, 0, directrix x equals 2. Mathematics grade 11. 112. B focus at F, 3, 3, vertex at V, 3, 2. C vertex at O, 0, 0, axis y-axis, passes through A, 1, 1. 9. For each parabola whose equation is given below, find the focus, vertex, directrix, and axis. A, x1, 2 equals y plus 2b x2 equals 6y. C4, x plus 1, equals 2, y plus 2, 2. 10. Write the equation of each ellipse that satisfies the following conditions. The foci are F, 3, 0, and F, 3, 0, vertices V, 5, 0, and V, 5, 0. B. The foci are F, 3, 2, and F, 3, 2. The length of the major axis is 8. C. The foci are F, 4, 7, and F, 4, 7. The length of the minor axis is 9. D. The center is C, 6, 2. 1 focus is F, 3, 2, and 1 vertex is V, 10, 2. 11. Find the foci and vertices of each of the ellipses whose equations are given. Of 4x2 plus y2 equals 8b2 2, 1, plus 2, plus equals 149xy. 12. Give the equation of a hyperbola satisfying the following conditions. Of foci at F, 9, 0, and F, 9, 0, vertices at V, 4, 0, and V, 4, 0. B foci at F, 0, 6, and F, 0, 6. Length of transverse axis is 6. See the foci at f 0, 10, and f 0, 10. Asymptotes y equals plus or minus 3x. 13. Find the vertices, foci, eccentricity, and asymptotes of each hyperbola whose equation is given and sketch the hyperbola. A 9x2 16y2 equals 144b22 plus 3 plus 1 equals 125 144xy. 14. An arch is in the form of a semi-ellipse. It is 50 meters wide at the base and has a height of 20 meters. How wide is the arch at the height of 10 meters above the base? Hint: take the x-axis along the base and the origin at the midpoint of the base. 15. An astronaut is to be fired into an elliptical orbit about the Earth having a minimum altitude of 800 kilometers and a maximum altitude of 5,400 kilometers. Find the equation of the curve followed by the astronaut. Consider the radius of the Earth to be 6,400 kilometers. Unit outcomes. Unit outcomes. After completing this unit, you should be able to know basic concepts about mathematical logic. Know methods and procedures in combining and determining the validity of statements. Know basic facts about argument and validity. PQPQQP TTTT TFFT FTTF FFTT. Main contents 4.1 Logic 4.2 Arguments and Validity Key Terms Summary Review Exercises. Mathematical Reasoning. Unit 4. Mathematics Grade 11. 114. Introduction. Mathematical reasoning is a tool for organizing evidence in a systematic way through mathematical logic. In this unit, you will study mathematical logic, the systematic study of the art of reasoning. In some ways, mathematics can be thought of as a theory of logic. Logic has a wide range of applications, particularly in judging the correctness of a chain of reasoning, as in mathematical proofs. In the first subunit, Logic, you will study the following: statements and open statements, fundamental logical connectives, or logical operators, compound propositions, properties and laws of logical connectives, contradiction and tautology, converse, contrapositive and quantifiers. In the second subunit, you will study arguments, validity, and rules of inferences. Historiae el no te. Aristotle, 384 to 322 BC. Aristotle was one of the greatest philosophers of ancient Greece. After studying for 20 years in Plato's academy, he became tutor to Alexander the Great. Later, he founded his own school, the Lyceum, where he contributed to nearly every field of human knowledge. After Aristotle's death, his treatises on reasoning were grouped together and came to be known as the Organon. The word logic did not acquire its modern meaning until the 2nd century AD, but the subject matter of logic was determined by the content of the Organon. Opiniing Perublium. Do you think that the following arguments are acceptable? Wages will increase only if there is inflation. If there is inflation, then the cost of living will increase. Wages will increase. Therefore, the cost of living will increase. Confused? Don't worry. Your study of logic will help you to decide whether or not this given argument is acceptable. Unit for Mathematical Reasoning. 115. 4.1 Logic. In this subunit, you will learn mathematical logic at its elementary level, known as propositional logic. Propositional logic is the study of assertive or declarative sentences which can be said to be either true denoted by T or false denoted by F, but not both. The value T or F that is assigned to a sentence is called the truth value of the sentence. 4.1.1 Statement and Open Statement. We begin this subtopic by identifying whether a given sentence can be said to be true, false, or neither. We define those sentences which can be said to be true or false, but not both, as statements or propositions. The following group work should lead to the definition. GROUPWORK 1 GROUPWORK 1. Discuss the following issues in groups and justify your answers. 1. What is a sentence? 2. Identify whether the following sentences can be said to be true, false, or neither and give your reasons. A man is mortal. Be welcome. C2 plus 5 equals 9 D4 plus 5 equals 9 E. God bless you. F. It is impossible to get medicine for HIV/AIDS. G. You can get a good grade in mathematics. H. X plus 6 equals 8 I. King Abba Jiffer weighed 60 kilograms when he was 30 years old. J. X plus 3. Mathematics grade 11. 116. From the above group work, you may have identified the following. sentences which can be said to be true or false, but not both. Sentences with one or more variables or blank spaces. Sentences which express hopes or opinions, as opposed to facts. Definition 4.1 A sentence which can be said to be true or false, but not both, is said to be a proposition, or statement. 2 A sentence with one or more variables which becomes a statement on replacing the variable or variables by an individual or individuals is called an open proposition, or open statement. 3 The words true and false, denoted by T and F respectively, are called truth values. Example 1 from group work 4.1 above, you see that a man is mortal. C2 plus 5 equals 9 D4 plus 5 equals 9 King Abba Jiffer weighed 60 kilograms when he was 30 years old, are all propositions. 2hx plus 6 equals 8jx plus 3. Exercise 4.1 Exercise 4.1. Identify each of the following as a proposition, an open proposition or neither. On his 35th birthday, Emperor Tewodros invited 1,000 people for dinner. B. Sudan is a country in Africa. C. If x is any real number, then x21 equals x1, x plus 1. D. You are a good student. Unit 4 Mathematical Reasoning 117. A square of an even number is even. F. Ombo is a town in Oromia. G8 9980 God have mercy on my soul. Ix is less than none. J is the study of plants. K for a real number 2xx 10 plus 4.1.2 Fundamental logical connectives, operators. Given two or more propositions, you can use connectives to join the sentences. The fundamental connectives in logic are or, and,